So this course is about bash scripting. You will learn with me bash scripting, creating real-world examples of bash scripting. However, since I want everyone, even beginners, to be able to follow this course, I created this section where I will go over all the basic commands that we will need and that you really have to know if you want to use the terminal. So don't worry, I will never use a command in the whole course that I did not previously explain to you. If you are an intermediate user or an advanced user, I suggest you to go right away to the next section about bash shell scripting right away. Otherwise, if you're a beginner or if you just want to be sure that your knowledge of the basics of the terminal is on point, is good, you can follow me within this lesson. So let's start from the beginning and let's move on without wasting any time. We are on a Linux system here. In particular, this is Ubuntu. And the first thing that you want to do is to find your terminal. So you have to go on your Linux system on a place where you can search your application or look for your application. In this case, for example, I go here, show application, and here you can type whatever application you want, and we type terminal. You see that it appears here, we press it, and here it is. Now this icon will appear on your bar, and if you want to keep this on your bar, you will right click and click the option to add it permanently on your bar. In my case, this is add to favorites. You might have something similar. So I click here so that when I close this is still here. It does not disappear. So now I can access the terminal from here. The terminal is simply a window where you can ask to perform some action. So if you type something that the system in the terminal does not recognize, it's going to tell you that it didn't find this command. Okay, so what you type here is what you want the terminal to perform. Okay, so an example is, let's say that I want to know what is the current directory that I am in right now. To do that, I will ask him to print my working directory, and this command in short is pwd, as in print working directory. So I hit enter and it tells me, okay, you are in the folder home and fra. This is the first and very simple thing. The second action that you can ask to perform to the terminal is to know what is the content of this folder, and you do that with the ls command, a short way to write list. You hit enter, and as you can see, we have the list of all the folders. And as you can see, we are actually here in this folder, and there is a folder, desktop document, and so on, and these files, atxt, etc., which is exactly what we have here. Now, I told you that when you type something that the terminal does not recognize, you get an error. However, there is a nice and useful thing, which is the hash, which allows you to write everything that you want. This is a symbol to write comments, so I can write anything now. And as you can see, I don't get any error. I can literally write whatever I want. It will not consider this as a command, but just as a comment. This might seem not very useful to you, but I guarantee you that in bash scripting, which is what we will focus on, this will come very much in handy. Now, when you mess up a little bit with, with your terminal, at a certain point, you might want to clean all this. You would like to have, again, a clean window. And in order to do that, you can type the command clear, that clear your screen. However, if you go up, you will see that you still have everything back. Now, let's see how, for example, I can list the content of this folder. So how do I do that? Of course, I will just ask the terminal to perform the action of listing this folder. So I write ls a folder. And as you can see, I get this, which is the content of a folder. Let's check this. You can see that here. So now we saw how to know where we are with the pwd command, to know what we have inside our working directory or inside some directory. Now we want to know how to move around. So let's say that I want to actually go inside a folder. Well, what I do is I ask the terminal to perform the action of changing my directory to this A folder. So I will type cd, change directory, to a folder. And now I am inside a folder. And in fact, if I press pwd, it will tell me you're inside home fra a folder. And in fact, if I now list what is inside my present working directory, so I use the ls command, of course I'm gonna get the list of the content of this folder, which is this, as we know. Let's do that. And you can see that here. When you list the content, you might wonder, well, here I see that this is a folder, but here I don't understand if these are folders or file. How can I know that? Well, ls come with an option that is -l, so you go ls -l. They give you a list in a long format, and long standing for with more details. Okay, so you do that, you type enter, and now you see that you have all your content here, and here you'll get some information. And the first character here will tell you if this is a file or a folder. So if you have a dash here or a minus, it means that there is a file. And if you have a D, it means that this is a directory, okay, so a folder. Another way to know that is with the -F option. And this will add a slash like this to all the items that are folders, and it will add an asterisk to all the items that are executable files. So in this case, I can right away understand that this is a file normal, this is a file that is executable, and this is a folder because we have a slash here. Anyway, if you want more information, ls -l could be your option. And don't worry, we will talk about it in much more detail in a later lesson. We saw that if I now try to list the content of a folder, I have to go ls and the name of the folder. So ls, this name takei.uk, and I get the content of the folder. And of course you can use the ls -l option to this folder. And you will have the content, as you can see, but in a long list, in a long format way, so with much more information. This is something you can also do with files. Let me clear the screen. So again, if I have ls and for example I want the long list information about this file, particular file here, I would just go ls -l and I get this information. So you might notice the difference of the behavior of ls -l. When you use it on a file, it gives you the information about this file. But when you use it with a folder, it gives you the content of the folder, as we saw. So what if I don't want the content of the folder, but I want information, just information about this very folder? Well, you would use also the D option here, so that when you list this folder, you don't get the content, but you get the information about this folder here. So in this lesson, we saw the very basic commands of the terminal. We saw how to know where we are with the pwd command, and how to access a particular folder with the ls command, and different options for the ls command like ls -l, ls -d, or ls -f. Also, we started to see how we can move around folders with the cd command, the change directory command. Now in the next lesson we will keep learning the basics of the terminal, and we will see how to move even with more ease around directory in the terminal. So stay tuned and see you in the next lesson. In this lesson we will see more in details how to move around files, and in particular how to use relative path and absolute path to files, and also how to move to the previous directory or the parent directory that we are currently in. Then we will see how to use the completion tab in order to save time when we type something in the terminal, and also how to find hidden files in the terminal that you cannot normally see in the normal window editor of your system. We are now inside a folder, and we can go even deeper inside this folder. So now I am in home fra a folder takei.uk. Now, how do we move back to where we were in a folder? Well, we can use the ... command. If we go cd ... this double dot means back one folder. So if I type that and I go pwd, you can see that I am back one folder. If I want to go back even once more, I can do that again, cd ... And so I am in fra. And I can go back again and again up to this one. And this is very important because this is the root folder, is the folder that contains everything else. So now let's say that we want to move back to this folder here. We can do a couple of things. We can go cd and then home, and then cd fra, and then cd a folder, and then cd this. Or let me move back. Or we can do that directly. cd home fra a folder and tki.uk, and I'm back here. Now there is an option very useful for cd, which is, let's say that now you want to go back to where you were. So we were here in the root folder and now we are here. If we did that with the dot dot, we should do dot dot a lot of times before we get back to this folder. But there is this very useful option, which is cd dash. cd dash will take you where you were before starting to use the cd command. So I type that, and as you can see, I'm back where I was. So let's move back and fra. Another thing that I want to show you is that if I want to go in any, if I want to change directory to any of this directory, we saw that we can go cd and then the name of this directory. However, there is another way, which is called the absolute path. And the absolute path tells you that you always can access any folder by telling the path starting from root. So starting from this one. So if I want to access a folder, yes, I can go cd a folder, but I also can give the full path of a folder, which is root, and then home, and then fra, and then a folder. And as you can see, I am back in a folder. A particular folder in your system is the home folder, is the folder where everything starts. My home folder, for example, is the fra folder, and you can access that anytime by simply pressing cd with nothing added. I go right away to this, which is my home folder. I can be everywhere. So I can be inside root, press cd, I right away go to my home folder. When you type something like cd a folder tki.uk, this is called a relative path. And this is a relative path because it is relative to where you are right now. And right now, as you can see, you are in home fra. So this path is relative to where you are right now. So let me leave that as a comment here. And this relative path is to contrast with the absolute path that we saw earlier, which is the one that starts with home, fra, a folder, tki.uk. This will bring me exactly to the same place, which is this folder here. The last thing, if you don't know that, is the completion tab. If I go ls and I want to go inside documents, I can go cd and go capital D O C. And now, if I want to complete this, I can hit the tab key, and the terminal will understand that I want this name here. So I hit tab, it completes that for me. And this works independently of the command that you're using. Even if I use ls and I go ls sum, and then I hit the tab completion, it will understand that I want to go here, that I want to write this name, as you can see. Sometimes there might be some normal confusion. For example, if I type do and I hit tab, he cannot understand if I want this or this because they both start with do. So I hit tab, it does nothing. If I hit tab again, it will tell me, what do you want, this or this? And so I'll go maybe, okay, I want download, so I put a W, and now I can hit the tab completion because there's just one name that starts with capital D O W. And inside downloads, there's nothing apparently. The last thing that I want to show you is the option of the ls command that can shows you the hidden files. If we look inside our home folder, we have all these files and folders, but no more than that. However, there are always hidden files, which are files or folders that starts with dot. You cannot see them if you do this ls like so, but you can see them if you go ls and the option -a. And as you can see now, you can find a lot of files that they're not here. All this dot If you want to see which one of those their folders, we can add the capital F option. Now, for example, we see that all these are folders. So for example, we can go inside the .java. So we can go cd.java. And now we are inside this, and we can list what is inside. We have fonts, for example. And this is not something that you can see here. In the next lesson, we're going to see more basic commands, like for example, how to copy or remove a file, or how to move a file in another place, or how to rename it. So very good for this lesson. Let's move on to the next one. In this lesson, I want to show you that the terminal on a Linux system and a terminal on a Mac machine are basically the same thing. And this is because both the Linux and the Mac are built upon the Unix system, which is the same, okay? So here I am on a Mac, and what I would do to find and work with the terminal would be again to go where I can find my application, type terminal. I'll find it. And here I would have my terminal, and back down I can go, right click and ask for it to stay here, going by option and keep in dock, so that when I close this, this icon will stay here. And here I can do exactly the same that I showed you in the Linux system. So if I want to know the present working directory, I'll go like this. I am inside user MacBook. If I want a list of everything inside, I go like this. If I want a long list format, I go ls-l. That's exactly the same. If I want the list knowing which one is a folder and which one is an executable file, I go -f. And I can go inside, for example, this folder with the command cd, some script. I can list the content. If I want to use an absolute path, let's say an absolute path inside desktop, I can go cd, user, MacBook, desktop, and here I am. If I want to go back to where I was, I can use cd dash. I can use comments here, and so on and so forth. Everything is exactly the same. There are very, very few differences, but the nice thing is that in this course, when there is a slight difference, I'm gonna address that difference very thoroughly, showing you what happened on a Linux and what happened here. But everything else is 100% the same. There is no difference. So in the next lesson, I'm gonna show you the copy command, the remove command, and the move command. So let's go to the next lesson. In this lesson, we will see the copy command in details. And what we will learn will be useful also for the move command and the remove command. So let's see how it works. But before that, let me show you something that we will need. We saw how we can move back using the double dots. So if I do cd ... I am back one folder, and we can go back like this. Also, I can, for example, list the content not of this folder but of the previous folder. So I can do that again with a double dot that will indicate list me the content of the parent folder. As you can see, we can see that it is actually the content of this folder by copying this and pasting the whole path here. And as you can see, it's exactly the same. Now, in a similar way as the two dots represent the parent directory, a single dot represents the present directory. So if, for example, we go ls dot, it means list me the content of this present directory, as you can see. Now, you might wonder, why should we need that? Because the ls without anything gives me the same result. But you will see that in action with the command like copy, move, and remove. So let's see how to copy a file. We are inside this playground folder, and there is all this stuff inside, as you can see here. Now, in order to copy something, we will use the cp command. The cp command works in two ways. The first way is to copy a file, like for example this file blah, giving it another name. So I can go copy blah, and then as a second input here, I put the new name that I want for it. So blah_2, for example, or anything that you might want. And I hit enter, and as you can see now we have blah here, and we have blah2, which is the copy of blah here. The second way in which you use copy, if you want to copy some file inside another folder. So for example, let's say that I want to copy blah inside dir9, directory 9 that contains this stuff instead. I will go copy the name of the file blah, and then the name of the directory where I want to put this file. So for example, let's say that I want to put that inside dir9. And as you can see now, blah is inside dir9. There is an option that can be useful with copy to understand what's happening, because as you can see, whenever you type these commands you don't get anything, and this means that everything is okay. But if you want to have a more verbose output, you use the -v option that stands for verbose, that gives you an output on the terminal so that you're sure that everything is working correctly. So let's say for example that I want to copy blah2 into a new file called blah3. I hit enter, you see that it is copied to blah3, and also we have an output of the terminal telling me that this file is being copied with this other name. And the same goes if I want, for example, to copy blah3 inside dir9 with the verbose option. I hit enter, and as you can see it was copied, and I get this blah3 was copied inside this directory. And let me remove these files here. I want to show you that you can copy multiple files. For example, I can copy the file blah and also the file blah2 and also let's say info.txt at the same time inside, for example, dir9. And let's make it also verbose so that we know what's happening. So we're copying these 3 files inside this directory. And as you can see, there were 1, 2, and 3 that were copied, and we can see the output here. Now, if you try and copy something that is already there, so let's say I try to copy blah inside here, blah inside dir9, I get this output that nothing happens. Let's say that I want to avoid something like that. There is a nice option about the copy file, which is the -i, in which when I try to do something like that, it tells me that already exists in dir9. So he asks me, do you want to overwrite this file with this new file that you're copying here? And then you can say no or yes. In this case, I write no, and it tells me not overwritten. If you try and do that with the file that is not existing, like blah3 is not here, it will not tell me anything because there is not here. But if I try to do that now, as you can see, it asks me. Now I can say yes. And as always, you can use more option on the same command. So if I want to make it interactive with the -i option, and I want also to make it verbose, I can use the -i and the v option. So in this case, I get this, and then for example, I write yes. And as you can see now, I also get the verbose output that I was not getting before because I added this option here. Now let me remove blah2 and 3 here. And let's say that we go inside dir9, cd dir9. Let's see that now I want to copy blah2 in the previous in the parent directory. So I'm dir9 and I want to copy blah2 in the directory playground. So here, how would I do that? Where I would do copy blah2 in the parent directory. So ... And as you can see, we get blah2 here. Now let's say on the other hand that I want to copy this file, dir9zip, inside where I am right now. So what I would do, I would copy ... dir9.zip, where here, where I in this present directory. And as you recall from the start of the lesson, I do that with the dot. And as you can see now, I copied this file exactly here. The last thing that I want to show you is in case you want to copy whole directories. So I am back inside playground, so here, and I want to copy dir8 inside dir9. So if I try to do copy dir8 inside dir9, I would get an error. And the error is that these are directories. So I have to use an option for directory, which is the -r, which stands for recursive. And recursive means that the system has to recursively copy everything that it finds inside dir8 and put it inside dir9. And if I do that, As you can see now, I copy the whole directory dir8 inside dir9. Now, once you understand all of this, you understand pretty much all the other commands alike, like move or remove. So in the next lesson, we will see in details the command move and remove, and we will apply what we learned here with the copy command to those commands as well. In this lesson, we will see how to move files, how to remove files, and how to rename files. And to remove files, we use the rm command. So let's say that I want to remove blah, I just go rm blah, and it's out. Let's say that I want to remove blah2 with the verbose output, I would go rm-v, and it tells me that it's removing this file. And again, let's say that I want to remove dir8, so I will go remove. I am inside playground, so I have to specify that dir8 is inside dir9, so I will go remove dir9 / dir8. But as you can imagine, since dir8 is a directory, this is not going to work. And you see that the terminal tells you, hey, this is a directory, so you better use the -r option, the recursive option. So again, we put the -r option here, erase this directory. And as you can see, we got rid of that. Just a word of caution. In many Unix systems, when you remove a file, this is gone for good. It doesn't go inside the trash, so you cannot recover it. Okay? With remove, files are gone. So remember that and really be careful when you remove files in the terminal. And since the remove command is so delicate, now you can appreciate this option here, which is the interactive option -i, when you want to remove something. If we want to remove, for example, the file blah with the interactive option, it is gonna ask me if I actually want to remove this file. So I can go yes or no, and if I go no, this is not going to be removed. The last thing, very similar to the copy command, is the move command, how you move file around. And you do that with the mv command. So you can move, for example, let's say that I want to move file A here. So I go inside dir9 and I find file A and I want to move that here. So dot. And as you can see, file A was moved here. It's not present anymore inside dir9, it's present here. Let's move it back. We want to move file A inside dir9. And as you can see, we moved it back here inside dir9. Again, you can have a verbose output. So we want to move file A again back here with the -v option. You see that we have this output. And if you want to move the whole directory, for example, dir8, you want to move to dir9, you would go move dir8 inside dir9. And in this case, this is only command that does not require you to add the -r option, the recursive option. It does that directory. As you can see now, dir8 is not here anymore. It was moved inside dir9. The second use of the mv command is to rename files. So let's say that I want to rename file A as something new. I would go move file A into something else, a new name.txt file. Now I hit enter, and as you can see, file A was renamed in new name.txt. So very good. In the next lesson we will see how to access files. In this lesson we're going to see how to access the content of text files. And there are three main commands to do that: the cat command, the more command, and the less command. So we are here and we have these txt files. The basic way to access, for example, the content of this file long new text would be cat and then the name of the file. And as you can see, I get all the content of this file. There's an option that can come in handy with the cat command, which is an option that lets you have all the lines numbered. If you want that, you use the -n option and then the name of the file. As you can see now, you have all the lines numbered. Now, what the cat command actually does is to concatenate files. So that means that you can use the cat command with multiple files and their output will be concatenated one after the other. So for example, let's access the content of text1. It's this kind of table-like content. Now, if we want to concatenate both of them, we can go cat text1 and then long text. And what happened, if I go back here, you'll see that it concatenated the output of the first file, text1, with the output of the second file in one single element. And of course you can do that with multiple files. We can do that with text1, long text, and then let's add info.txt. And as you can see now, we have concatenation of the first file, the second file, and at the end the content of the third file. The last thing that I want to tell you is that the option -n works, of course, even if you're concatenating more than one file. As you can see here, we have the numbered file, and then when another file starts, you have the numbering that starts over. Then again, here we can see that there is another file because we have the numbering starting over again. Another thing that I want to tell you is that cat can also be executed without any file here. And when it is executed like that, what it does is it takes input from the keyboard. So whatever I write here, it concatenate the same thing as an output. So I hit enter and it gives me hello. If I write everything like so, it will write the same thing, and so on. If you want to close that, you can go either Ctrl+C or Ctrl+D. So I typed Ctrl+D and I'm out. Now, this is the first way you can access the content of the file. The problem might be that if you have very long text, the cat command takes you to the end of the file. So if the file is extremely long, then you have to scroll back to the start of the file. And there are some login files that can be very, very long. So what if you want to have a clear view of the start of the file instead? Well, in this case, you can use the more command. So you can use more, long new text, and you see that you're at the start of the file here. Then what happens is that you arrive to a certain point, and then you can go with the arrow keys, the down arrow keys, okay, and up. When you're finished reading what you're interested in, you can press Q and you're out, as you can see, and it cuts the file wherever you pressed Q. On the other end, you can go down up to the end of the file, and when you reach the end, you go back here. Now the third way you can access the content of a text file is the less command. Because both the cat command and the more command, they leave the content of the file on the screen of the terminal. But what if you just want to access the content but not leave it on the window of the terminal? In that case, you can use the less command. So I'm here, I use the less command to long new text.txt, I hit enter, and I'm here and I can see whatever I want about this file. But as you can see, I am in a kind of a separate window. And so I can read it, and when I'm done, I can press Q. And when I press Q, as you can see, I go back to where I was, and no output was printed on this screen. Okay? Another useful thing about the less command, which I use quite often, is that when you are inside this window here, you can, for example, search for words. And you do that by pressing the /, and you see it appeared here when I type that, and then whatever you're looking for example, let's look for integ, and as you can see, it finds for you every instance of what you're looking for. You can find the next instance pressing N, and you go back to the previous instance pressing B, the B key, and again you can go down with the down arrow key, and so on and so forth. And when you're done, you just press Q and you're out. So very good. In this lesson we saw the three main ways of accessing the content of a text file and why you would want to choose one over the other, the cat command, the more command, or the less command. So very good, and see you in the next lesson. So in this lesson we will talk about the echo command, and in particular the echo command with the -e option that lets you use the output in a more precise way. The echo command is a command that lets you print whatever you want out in the terminal. So you type echo, and then inside comma you can type whatever you want, like hello guys. Now you can do that even without commas, like so, but as you can see you can have some problem because without commas the terminal is going to interpret symbol like this parenthesis as a part of a command. So that is why you usually don't want to do that. If I were to just use hello guys like so, as you can see it's working, but whenever you use something else that might be misinterpreted by the terminal, you can have problem. That is why you usually want to use commas. There's not a lot to talk about the echo command, it's just print out whatever you write in. If you want to use the echo command in more details, for example, you want to use a new line, you're gonna need the -e option. Let's see that. The -e option lets you use new lines or tabs or more specification of the sort. Echo command will work like so. Hello there, and it prints that out. But what if I want to have a new line between hello and there? Well, I would go to -e option, and then I would add a /n, and the /n indicates a new line. And as you can see now we have hello there. If you don't want to have this space here, you can put the there just right after the n character, and you get this clear output. Another useful option is a tab. If you want to have a tab between hello and there, you would use tab. If you want to have a more tab, you just put another /tab and you get two tabs. By default, when you use the echo command in every way, what happens is that after the output you have a new line. This is in most cases desirable, but if this is not what you want, you can use the /c option that cancel a new line. And as you can see after the output there is no new line, we start back here. Another option that you have with the -e is the vertical tab. So this is easier to show you than to explain to you what a vertical tab does. I go hello, and then I go /v, and then there, and it's gonna put a vertical tab between these two, as you can see here. See, hello, and then a tab here, and then there. That would be the same of doing this, hello, and then a tab, and then after the tab a new line, and then after the new line a tab, and then after the tab there. You see, that's pretty much the same thing, and you can play with it as much as you want. You can put another tab here and do whatever you want, but this vertical tab does exactly that, and you can use that as many times as you want. For example, hello, vertical tab there, and then vertical tab guys, and you can go as long as you want with this. So these are the main more useful option that you can use, the more useful specification, the more useful way to arrange an output with echo command. And always remember to put the -e here, because if you don't put the -e here, it's not gonna recognize those, okay? It will not recognize the slash and then a V, okay? So with this simple specification here, we can get a much clearer output from the echo command. And when you want a clean output, that is something that can come in handy. And finally, this is something that we're gonna need in our script. So very good, and see you in the next lesson. In this lesson we will see how to create files and how to create directories. So the basic command to create a file is the touch command. touch command works very simply. Now we are in playground. Please go touch my file. And as you can see, this new file was created. Of course, you can create file with whatever extension you want. For example, if you want to create a file.txt, you can do that. As you can see, now we have this file, which is considered directly a txt file. And usefully enough, you can use the touch command with multiple files. So we can do that with f1.txt, but also f2.txt and something else .txt. As you can see, we created these 3 files here. The touch command has also another important use, which is to change the time that a file was last modified. For example, f1.txt was last modified January 21st at 2015, which was what we did when we created that. Now let's say that I want to change this time, but without modifying the file. A very fast way is to use the touch command with this file f1. So as you can see, now it's 2053. I'm gonna hit enter. And now what we get is the following, that in fact our f1 now shows a time of last edited that is changed to 2053. Now you might wonder why you would need something like that. Well, the point very briefly is that there are many programs that deal with your files depending on the time they were last edited. So let's say that there is a program that has to update a certain kind of files. It might very well be working checking the time of the file, and if they're too old, this program is going to update those files. So it's just a very simple example of why this timing is very important. And so you can change this time with the touch command without touching anything about the file, which can come very much in handy. Now let's say that you are in a folder with a lot of files and you want to update the file info.txt. Well, let's say that you're not sure that this file exists or not. And when you're running bash scripting, this can be very well the case. And let's say that you just want to touch it. You don't want to create in case it doesn't exist. Well, you can do that with the -c option. So if I run something like blah, 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 something that does not exist, touch -c, it didn't create anything. On the contrary, if you use that with something that exists, like new name, it changed the timestamp to exactly right now. In this lesson, we want to see how we can create folders. So we create folders with the command mkdir. So let's say that I want to create a folder that is called fold1 inside here playground. I just hit enter, and as you can see, you have your folder 1. As for most of the other commands, you can use that with multiple inputs. So as you can see here, let us remove those folders. And as many other commands, you have the verbose option here. So when you do like that, you have the output that is telling you that it has created this directory folder 1, 2, and 3. Now, of course, you can create a folder wherever you want. So for example, let's say that in folder 1, we want to create a folder called sumf. We'll go mkdir, go inside folder 1, and inside folder 1, create me, please, the folder sumf. If you hit enter, you see that now inside folder 1, there is sumf. Now, there are some situations where you want to create both the starting folder and the child folder, the folder that is inside here. So let's say that I want to create a new folder, and inside new folder, I want also to create some folder 1. Now, the problem is, as you saw here, this cannot work because the system is gonna understand that this folder exists, and so it's going to try to create this one inside an existing folder, but new folder does not exist. So if I do that, of course there is no such directory, so I cannot do that. So how can I create both this folder and this folder? We can do that with the -p option, -p. Now in this case, it will create both of them. So I hit enter, and as you can see now we have new folder. And as you can guess, inside new folder, we already have some folder 1. So very good. In this lesson, you learn how to create a new file, how to change the timestamp of the last modification of the file, and how to create multiple folders, and also how to create nested folders. So now you are ready at the point where you can do many things in the terminal. So very good, and see you in the next lesson. In this lesson we will talk about wildcards. Since the shell uses file name so much, it provides us with the special characters, and these special characters help us to rapidly specify groups of file names. These special characters are called wildcards, and we're gonna look at them one by one and what we can do with them. The first character that we're gonna see is the star sign. The star sign indicate any characters. So any characters in any number. So for example, these are my files, and if I want to list, for example, only of the txt files, I can ask, give me the list of the file names that start with anything, and so I put a star sign, and then I put .txt. And as you can see, we only get the .txt. For example, I want only the files that start with the letter D, we can go ls, D, and then star. So it means give me everything that starts with D and then have anything after that. And as you can see, we just get the files starting with D. And usually they're very useful for that. For example, let's say that we want to move all the files starting with D inside this folder, folder 1. So inside folder 1, we have this. I can copy all the files starting with D inside folder 1, for example. And now if I list the content of folder 1, as you can see, we have all of those. Or I can remove those. Let me remove everything that is inside folder 1 and that start with the letter D. Now if we list again folder 1, you see that we don't have them anymore. The second wild character is the question mark. The question mark is any single character. So it represents just one character. So for example, what if I want to list all the txt files that has only 2 characters in their name? I would go ls question mark representing 2 any characters and then .txt. And in this case, as you can see, we only get these files here, ab.txt and cc.txt, because they both have just 2 characters. Of course, if I wanna those that has only 3 characters, I can go like that. And now you see that we get these guys here, 123.txt, Bob and Web, because they all have 3 characters in them. But if I look for something like this, file that has just 1 character, we won't find them because we don't have files that just start with 1 character. Now, what if we want to be more specific? What if I want to say, for example, that I want only the files, only the txt files that starts, for example, with the letter A or B or C? For that, you have the character class. The character class is something like this. You have square brackets, and then you put, for example, A, B, C. And these represent A or B or C. So for example, let's say that I want to list every file that starts either with A or B or C, and then has whatever we want, and then .txt. And as you can see, we get only the txt files that start with either A, B, and C, but we don't get, for example, web.txt. If we wanted only the file that starts with A or W, we would go like that. And as you can see now, we get only the files that starts with an A or W. We can combine those. For example, let's say that I want only the files that starts with 2 characters that are either A, B, or C for the first one and A and B for the second one. We find this file here. But if we add here C, we find this guy, but also CC. There is a nice way to exclude the character, which is the exclamation mark or the bang. This exclude character. If I don't want a letter A, B, or C, I can go not A, B, and C. So this is any character that is not A, B, or C. So for example, if I go ls abc and then anything.txt, I get these files. But if I go like not A, B, and C, you see that I get everything that starts not with an A, a B, or a C, everything else. If, for example, I'm more specific and I don't want also the D and I don't want the W, we start getting fewer and fewer elements, and we don't get, for example, this guy here because it starts with a D, and we don't get this guy here because it starts with a W. Of course, this character class works with numbers also, or with whatever character that you want. For example, if I want the file that starts with 1, 2, or 5, and then they have anything you want, and then they end with .txt, I get all these files. But if I want the files that start with the number 1, 2, or 3, I go like that, and you see that I don't get this anymore. At this point, you understand that, for example, if you just want to work with, at this point, you understand that if you wanted to, for example, specify all the letters, you should go A, B, C, D, E, F, G, H, I, J, and so on and so forth. And that is a little bit long. So for that, in the shell, you have the option of specify character classes. Character classes like, for example, this one, alpha, which represent only letters, only the alphabet. So for example, if we go ls, you get everything that starts with a letter, and you see you don't get anything starting with, for example, numbers. In the same way, if you want just number, you can go digit. If you want something starting with a digit, you go like this, and you see that we just get things starting with numbers. And if you want to be more specific about letters, you also have the option in the lowercase letters, and the character class for those are simply written as lower in this way. And as you can see, you get everything, but for example, you don't get this one, alex.txt, because it starts with an uppercase letter. And in the same way, if you want only those starting with an uppercase letter, you would go upper. All these wildcards that I showed you, you can combine them in any way you want to really perform accurate and precise action on the shell. In this lesson, we will learn about variables in the terminal, and in particular, we will see how we can manipulate variables, how we can, for example, cut the starting part of a variable or the ending part of a variable, depending on our needs. So let's get started. The first thing that you want to know is that to set the variable, you just have to use whatever name you want. For example, we can call our variable Bob, and we can say Bob equal 130. And now if you want to access the value of this variable, you do that with the $sign. You go $sign Bob, and you see that we can access the value of the variable Bob. A more precise way to access the value of the variable is to use the $sign with the curly braces like that, so that it's perfectly clear what is the name of the variable. It is what is inside the curly braces. And let me give you right away a practical example of why this is a better way of accessing a variable. Let's say that we set the variable A as my file, for example, like so. Now, if I wanted to append something to this string, like for example, my file_1, and if I try to do that just by writing _1 after my variable, we would not get anything. And this is because the system is interpreting all this as a variable that does not exist. If instead I use the curly braces with a here and _1, now it's very clear that the variable to access is a. And so if I hit enter, you see that we appended that successfully. And we can really add whatever we want. Of course, if you forget the $sign, nothing will happen and you will just echo out whatever it is that you're writing, in this case Bob. And of course also you can combine that with whatever output you're writing. For example, this is my value. As you can see, we get this is my value and then the value of the variable Bob. Pay attention to how you assign the value of the variable, because you don't want to leave spaces. For example, if I write Alex and then I leave a space and I write equal 100, this is not going to work. It will interpret Alex as command. The same thing goes if I leave a space after the equal sign. Again, you want to go something like that. Now you see that it's working. And of course you can assign to a variable whatever value you want, also a string. So for example, inside p I can put the value, we get our string. If you try to access a variable that does not exist, for example this variable here, you don't get anything. And I'm telling you that because I want to show you how you can unset a variable. How can I unset the value of p? I just use the command unset p. Now this isn't set, and if I go like that, as you can see, this is not set anymore and I don't get anything. We will see this command also in use with arrays. Let's now turn to some more advanced features of variables. So we already know how to set a variable. The first thing that I want to tell you is that there is a way to know the length of a string, so how many characters it contains. And to know that, you simply add the hash symbol in front of the variable, like so. And you get that we have 9 characters in our variable a. Of course, it works also with any string that you can write, like hello there, as you can see. The second thing that I want to show you is the extraction from a string. So let's take back our string a. Let's say that I want to start from a specific point here, for example, from the 4th character. What I can do is do a column 4. And this, we can do that with b also, if we want to start with the 4th character, which is 1, 2, 3, 4, which is the L. I go b column 4. And as you can see, I start after the 4th character at the O. If you want to be more precise and tell exactly the length of the string that you want to take after the 4th character or after any character that you choose here, you go b column 4 and then you add the length. So if I want to go for 3 character more, I hit 3, and now as you can see, I start from O and then I get O, the empty space, and T. So 1, 2, 3 character. If I want to go longer, for example 6 characters, I get 1, 2, 3, 4, 5 and 6 characters starting from the 4th. Okay, this is even more clear if we use the a. So a starting from 4 is this. If I want to move for just a couple of characters, so 5 and 6, I type 2 here. Sometimes it is useful to count the characters from the end, and you can do that using negative number. So again, this is our variable a, and if I want the last 3 characters, I can go a column space -3, and I get my last 3 characters. Pay attention, because if you don't put space, it's not going to work. This is not going to work. And Of course, I can go deeper, like the first 8 characters, so I almost take everything. If I go -9, I'm gonna take the whole thing here. This is the same as telling start from the 0 character. Okay, the 0 character is before the first one, so I'm gonna take everything. If I start from the first, I'm gonna take out the first. Of course, when you start from the end, like let's say that I start from the 4th character back, so I have this. In this case too, I can specify the length that I want to move on from this character here. So let's say that I want to move on just a couple of characters. I can add 2 here, and as you can see, we will have 6, just 6 and 7. And again, this works exactly the same if your variable is a string or a combination of string and number is a string. So I can go -3, so I want to start 1, 2, 3 from this character here. And in fact, I get ERE. And if I want to move just for a couple of characters, starting from here, so just take E and R, I'll go column and then 2, as you can see. Now we saw how to count the characters in the variables. We saw how to extract the content of a variable starting from the beginning or starting from the end. And now we want to see how to remove a part of our variable. Now let me show you how we can specify exactly what we want to remove from the start. So let's go back to our variable b. Let's say that I want to remove an h. If there is an h at the start, I want to remove the h. I can do that using the hash symbol after the b. So I go b, hash, and then I put the symbol, the character that I want to remove, in this case h. If I do that, as you can see, I remove that. If for some reason I wanted to remove the character w, but the character w is not present in my string, that would not affect at all my variable, as you can see here. And this is very handy in bash shell scripting when you want to remove just specific characters. And of course you can remove the h, or you can remove many things like HEL, L. So now I get this, or the whole LO string. Now I just get there. Now let's say that I want to remove everything up to this T here. Of course, if I type T, it's not going to work because this is the character that it looks for at the beginning. So if I do that, as I showed you earlier, it's not going to do anything. But thanks to the star character, I can do that. I can say erase everything that starts with something and arrive to a T. So I remove everything up to a T. So it will remove all of this. If I hit enter, in fact, you see that I get this here. Or up to an R. Of course, you take everything, and the only thing that is left is the E. This is very clear if we use the variable a. I say remove 1, 2, 3, for example. I just get that. Or remove everything up to 7. And of course, if I go something like this, it will remove everything completely. If instead you want to remove something from the end, then you want, let's go back to our variable a, and I want to remove something from the end. We use this symbol instead, the percent sign, the percent sign. So I want to remove 9, for example, from the end. And as you can see, it removed 9. I want to remove 7, 8, 7, 8, and 9. And so I go 7, 8, and 9. And again, if I ask it to remove something that is not there, I don't know, like 3 is not at the end here, it's not going to do anything. Or whatever thing I can write here, it's not going to do anything. And that is good for us. It's not going to mess around our variable if it doesn't find what I'm asking for. Also, when we type this, it found the exact string 7, 8, and 9. But if I were to type something like, I don't know, 2, 8, and 9, it will find 8 and 9, but it will not find 2, 8, 9. So this is not going to do anything again. If I want to remove, for example, everything from the end up to a certain thing, like for example up to 3, I can go remove everything in this way. Something that has a 3 and then whatever it is that you want. So in this case I'm asking for this 3 and then anything else. So, and again let me show you that with a string like this. If I want to remove from the end the string re, I would just go %re and it takes that out. If I want to remove everything starting from the L, I can go % and then L and then the star, and everything is removed. If I just want to, let's say that I want to remove there. If I want to remove there, I can go like this, T and star, which is much better than writing the whole there string. So in the last couple of lessons, we saw how to use variables to create them and access them, and in particular how we can manipulate them. For example, how to get the numbers of character that they contain, or how to cut specific parts of a variable from the beginning or from the end. And we saw how to do that in two ways, either counting the number of character from which we want to cut, or finding exactly the symbol that, or the symbols that we want to cut, making also use of wildcards like the star symbol, which is very, very handy in this case too. We will make use of some of these more advanced features of variables in a script that we will create later in the course. So very good, and see you in the next lesson. So we saw, for example, how we can set a variable, but what if we want to make this change permanent? So for example, I'm here and I want to set the variable that contains this name here so that I can use it later. So I can set the variable s equal pwd. And now we know that inside s we will have this. But if I go out the terminal and I enter again, if I try to access that again, we won't get anything. But there is a way we can make these changes and other changes permanent. Because you see, when you log in the terminal, the system will run as a first thing a login script where it sets all the important aspects that you will use in your shell, like variables, home folder, path. So what is this login script and where can we find it? It depends on your system, but it will be one of those, either .profile or .bash rc or .bash underscore profile or .login. And you can look for it in your system. For example, let's find this in both a Mac system like this one or in a Linux system where we have Ubuntu. The login script usually is in your home folder. So if you go ls and you look for the hidden file starting with a dot, so -a, in our case we have it here, .profile. So we can open this file, for example with the nano, and you will see that we have all variables set and many other things here. In a Linux system like this Ubuntu here, we go to home folder again and we'll see that we have ls-a and we have it here. So we can check this again. We have all the information here. Sometimes, like in this case, you have both .profile and .bash hrc. So if we open this, and since we know that this will be run every time that we start our terminal, we can play with it, for example, introducing an hello message, hello Ubuntu user. So if I save this, we can just close this and open the terminal again. You will see that now the system is running first thing that login script, and we have our message here. So this ensure us that the login script was exactly the right one. And of course we can do that in our Mac system here, opening the dot profile. We add echo hi. Now if we close this and we open it, you see that we have our login message. Now, once we know how to work with this login script, we can, for example, add a variable inside the login script so that it will stay there permanently. So coming back to our example, if I want to go inside library and inside, for example, cookies, and I want to save this as a variable, I can go inside I go to the home folder, and then I can add this as a variable. It's always a good practice to add a comment here, which you will do adding the hash thing here. Here you can type whatever you want, it will not affect anything. My variable. And then I will just type s equal. And then I will just add s equal and what I want s to be, so this string here. And I'm done. Just have to exit and save. Now, if I do that, it won't work now. It won't work right away because you have to source the profile or generally the login script. So you want to either to exit and go back again so that it runs, or if you don't want to go out from the terminal, you can use the command source. If we try and access our variable, we will have it here. And now even if I close this, I will be able this time to access my variable, as you can see. So right now, if I want to go inside this, I don't have to type this all the time. I just can go, for example, cd and that $s, and I am inside cookies, and then I can go back, or I can move or copy whatever I want from and to this folder. In this lesson, we will see how the read command works. So basically, the read command is a command that takes something in input and it uses a variable to store it. So for example, I can do read a and I hit enter, and then I type something 1 2 3. Now in the variable a, I get value that I put here. So if I access the value of the variable a via the usual $a, I get its value. If I want to proceed the acquisition of the value with a message, I can use the -p flag, where I can put a message here. Give me the value of the variable. And then we put this always inside the variable. Let's use, for example, q. And as you can see now, we have this message preceding the acquisition of the value. Like, I don't know, let's write Albert 1 2 3, and now inside q we will have our value. Something to remember is that if you don't give anything to the read command, like let's do read, and instead of read a, we do just read like that, and we hit enter, it will still read something. So let's write something like Papa, and I hit enter. Where was this variable stored? We didn't give any name for any variable here. Well, it's nice to know that this is always the case, that this variable will be put inside an environment variable called uppercase reply, as you can see here. If you do that again, I hit enter and I don't put anything, and I write, I don't know, hotel 34. Now in the environment variable reply, we will have this, as you can see. In this lesson, we will learn about redirection, how we can redirect the output of a command not to the screen, but to whatever file that we want. Now, in order to understand that, we have to understand how a command sends its message to the screen. And that's what we're going to do right now. Because people usually think that whenever we type a command and we hit enter, whatever happens is sent directly to the screen of our terminal. So whether it is the output, or it is an error message, both of these are just simply sent directly to the screen. The point is that this is not true. So let's see what actually happens. When we type a command and we have its output, this is not directly sent to the screen. Instead, this is sent to a file that is called stdout file. And the point is that this stdout file is directly connected to the screen. So whatever is present in the stdout file is sent directly to the screen and we can see it. And this is where redirection comes into play, because what we can do is to prevent this to happen and instead redirect the content of the std file to whatever we want. We can redirect this content where? To whatever file we want, some file that we created. How do we do that? What is the command used in the terminal to redirect this? Is the symbol 1 and then greater than sign. So before moving on, the second result of a command, which is an error message, let's see how in practice we can redirect the normal output of a command. And let's take, for example, as a command, the simple command ls-l. If we type this command and we hit enter, well, what happened is that the output of this command is sent to the stdout file and then directly to the screen. And that is why we can see the output of this command directly to the screen. But what if instead we want to redirect this to a file? Let's say, for example, that we want to redirect this output inside a file afile.txt. So how do we redirect the output of this command? We go ls-l and then we use the redirection command, which is 1 and then greater than sign and then the name of the file. Now we hit enter, and as you can see, now we don't see anything. Why is that? Because the output of this command was redirected to a file. In fact, if we go to see afile.txt, you can see that we have this output here. The first thing that I want to mention to you is that the redirection of the output also works without the 1 number here. So for example, we can redirect the output of the ls command simply typing the greater than sign and then bfile.txt. Again, we don't get any output here. Why is that? Because it was redirected inside bfile. And the last important thing that I want to tell you is that if you use the redirection symbol to a file that does not exist, that file will be created. So for example, let's go ls-l and then greater than sign, and let's create my new file.txt, which is not present here. Now we hit enter, and as you can see, this file was created right now, and its content, of course, it's the output of this command here. A very common use of redirection is done many times with the echo command. So if we echo something like hello there guys, but again we can redirect this, for example, to our afile.txt. So we go greater than sign and then afile.txt. Now if we check this file, you will see that we have hello there guys. You might have noticed that as soon as I did that, the content of this file was erased. And again, if for example now we do another redirection with something else, we hit enter, this is redirected to the A file, but the previous content, which was hello there guys, is no more present here. It is erased. So one way to avoid that is to use, instead of the simple redirection, the append redirection. And this is done with a double greater than sign or 1 double greater than sign. Again, it is the same. So for example, right now we have this file with something else. And let's say that we want to add a line to this file. So we would go echo, adding a line here. And then we will go 1 double greater than sign a file. And if we check now, you will see that the first line is still here and we added the second line. The last example of redirection of the output that I want to show you is with the cat command. We know that the cat command show me the content of this file, and if I use two files, the cat command will concatenate their output. Now this is very useful if you want to connect the output of two files into one single file. We would just go cat first file, second file, and then redirect that, so one greater than sign, a file. Now, as you can see, the content of a file is the concatenation of these two files here. Also, let's remember that the cat command without any input, when we hit enter, the output will go directly to the screen, as you can see here. You can understand that you can take advantage of that and use the cat command, but redirect whatever you write to a file, for example, the bfile.txt. Let's do that. We can do cat, and then we use the output redirection to bfile.txt. Now, whenever we write something, for example, hello there, and we hit enter, as you can see, it didn't send this output to the screen. Why is that? Because it sent this here. Look at that, hello there. Now, what if I type something else? If I type and I hit enter, look at what happened here. We have that, okay, and so on. Now look what happened to the file. We have exactly what we typed here. So very good. Now we have full view of how we can redirect the output and how we can append the output if we don't want to erase the previous content, and how we can do that with every command that we might be interested in. What we want to do now is to understand how we can redirect error messages of commands, and we will see that right now in the next lesson. In this lesson, we will see how to redirect the error message of a command, which is also called a status message of a command. The status message of a command. And we can do that again by understanding what happens in the terminal. Whenever you type a command and you get a status message or an error message, this is not sent again directly to the screen. Instead, it is sent to a file which is different from the stdout file, and it is called the stdr file. Okay, so the status message takes a completely different route, going to a completely different file, which is the stdr file. And this file also is directly connected to the screen. So whenever something is here, it is directly shown to the screen. Now again, what we can do is to prevent this to happen and redirect the content of the stdr file, redirect this content to some other file that we want. And of course, the command that we use to redirect the standard error cannot be the same one greater than or greater than as in the case of the output, because otherwise the terminal would not understand what you want to do. In this case, the redirection command is instead to greater than sign. And in this case, there is no shortcut. You always have to use to and greater than sign. You cannot omit that. Let's see that in practice. So we want to see now what happens if I type a command like ls-l, but then I use something that does not exist, like this name here, and so I get this error message here. What we can do if we want to redirect this error message to a file, we use this command, but then we redirect the error message with to greater than sign to, for example, bfile.txt. Now, as you can see, we don't get anymore an error message. And if we check bfile, you see that the error message was sent exactly here. Now, let me show you what happened if instead I, for example, redirect the output of this command here. Can you guess what it is going to happen? Since this command has just an error message, but it does not have any output message, the output message is empty, and so the B file will now be empty. So what happened? We still get an error message. Why? Because we did not redirect the error message, we redirect the output message, but the output was empty. So if we now check the B file, we will see an empty file. Now I want to show you a very interesting and real world example, because in many cases you can have a situation when you have both an output of the command and also an error message. So for example, if I go ls -l and then text1 and then text2, we get this output message. But what if I add another file that does not exist? Again, something like that. Well, what happened now is that we get an error message because this file does not exist, but we also have an output message because these two files instead exist. So what if I want to now to redirect only the output? Well, we can do this and then one greater than sign, and then for example, let's go a file.txt. Now, as you can see, the output was redirected to a file here, and the error was sent to the screen. So what if I instead want to redirect the error message only? Well, I would use this command, and then I would use 2 greater than sign to redirect just the error message. So the output message was sent, but the error message is no more there. Why is that? Because it was sent to a file.txt. Now again, in this case of this command here, what if I want to redirect both output and error message? Well, to do that, we can use this symbol here, the and symbol and the greater than sign symbol. So if you want, there is a way where you can redirect both standard output and standard error to the same file. And the symbol for that to happen is the and greater than sign, okay? This is the command that we want to redirect, and we want to redirect both the standard error and the standard output. We redirect that to, again, a file.txt. We hit enter, and look at what happened. We don't get anything. Why? Because everything was redirected to a file. Let's check this, and here it is, standard error and standard output. Now, I really want to tell you everything about redirection. So the last case that is remaining is that, let's say that you want to redirect the standard error to one file and the standard output to a different file. What can you do? You can simply just use both 1 greater than sign and 2 greater than sign. Let's see that. We have this command, and let's say that I want to redirect the output to a file called output.txt and the error message to a file called error.txt. So I use 1 greater than sign output, and then at the same time 2 greater than sign. I want to call that error.txt. Now hit enter, and as you can see, these two files were created. Nothing appears here, and if you see in the error file we get the error message, and in the output file we get the output message. I want to end this lesson also with a bonus about redirection that could come in handy, and this is about the folder dev null. You see, there is a folder in the Unix system that is called dev null, and the nice thing about this folder is that whatever is sent to this folder, it just practically disappears. So why would you want a folder like that? Well, now that you know redirection, you might have an idea. For example, let's say we go echo hello, and for some reason we mistype echo and we go like that. We would get an error. But if now you redirect the error message to dev null, what happened is that this error message is disappeared. An example that is a little bit more real world example is when you have a command that has the output that you want, but it is also giving you an error message that you really don't care about, and you don't want to deal with that error message because it is useless and it's only messing up your script. For example, using this command ls-l to these 3 files, let's say that we have another file that we don't know if it exists or not because we're running a bash shell script. Now, in case that it does not exist, you will get an error message, and you don't want that because probably you want to save or use this output, but not this. So what you can do here is to go there and use the redirection of the error message with 2 greater than sign to def null. And now you have a clean, simple output of your command and not an error message. So very, very good. We learn anything about redirection, and you really have a clear idea of what is happening so that you can use it in any way you want. See you in the next lesson. In this lesson, we're gonna see this command here, the pipe command, and it lets you do the following. It lets you use the output of one command, let's say for example command 1, as the input of another command, let's say for example command 2. So for example, if I want to list the content of a folder, I have this output here. What if I want to use the output of this command here as the input of the last command? So I want to look at this output, reading it with the last command. What I could do is I could do list a folder, and I would pipe in, that is the term you use, pipe in the output of ls a folder into the last command. If I do this, you can see that the output of list a folder was given as an input of less, so it's the same as less this input. Just to let you understand what it does actually, the pipe command is the same as doing the following. I could redirect the output of a folder inside a temporary file, temporary output file, just temporary output. So you can see, for example, if I read temporary output, there is this, and then I give the temporary output as the input of the command less. And I have the same result. So if you want to remember and understand how the pipe command works, you can remember this. The pipe command do the following. It takes the output of a command, it puts it inside a temporary file somewhere, and then it gives this to the last command. You use this as an input of the last command or the second command, whatever command you might choose to use. Let's see some useful command that you can use with pipe. Let's read this file here. A useful command is the tail command, which let me see just the last, let's say the last 4 lines of a file, like btext. You can see I can read just the last 4 lines. So for example, I could use this command for, again, for some command like as a folder, and I can pipe this command into the tail, for example tail -3 command. So I will see just the last 3 lines of this output, and here they are. And one last thing is that you can pipe as many commands as you want. So for example, we can do this, we can pipe this into tail, the last 3 lines, and then I want to use this in turn as the input of the last command. The last command, and you see I obtained what I wanted. And really there's no end to these. I can also, for example, before that I can sort alphabetically the file, and as last thing you can also pipe ls folder inside tail, the last 3 lines, and then pipe it inside sort, and then redirect this to some file, for example my new file.txt. Now if I watch my new file, you can see that I have the output of ls folder, of which I took only the last 3 lines, and then I sorted them in this file, my new file.txt. Very good. See you in another lesson. Now, if you want to search inside a file, the command that you need is grep. The grep command. Let's go inside new folder, cd new folder. We have the list of everything, of every file here, and let's see what is inside btext. Now let's say that I want to look for a line where there is the words, for example, SO. So what I do, I simply type grep, and then I put what I am looking for. So for example, SO, and then the name of the file that I am searching, b.text. And it tells me, okay, I found something, and in fact this is this one. Now if you pay attention, you see that it didn't mention son. This is because grep is case sensitive. So if I were to do grep so, I would find that line instead, but not the first one. You see, it told me you can find son, but it didn't mention something. Very useful command. You should use grep usually always with this option. Very useful option is to make it non-sensitive. So you add the option insensitive. And then we look for so inside btext, and you see that now it gives me both something and son, regardless to whether they are uppercase or lowercase. Of course, you can look for just S, and if you pay attention, you will see that it gives me all this line. And you have to remember that it's not just giving me the word starting with S, but the line that contained S. For example, here it's at the end, here it's at the beginning, here is in the middle. There is an S here, okay? So grep work in this way. Another useful way to use the command grep is with the pipe. For example, if I list everything I have here, something useful might be to look for something that has the letter T in it. So for example, I could go ls and then pipe into grep looking for T's, for example, and you see it gives me all this files. A useful command, for example, for grep is -v. So if we list here everything, and for example, I'm interested in the file with T, I do ls, and then I pipe into grep T, and you see I find all of this. Very useful option for grep is -v, which gives you everything except what you put in the command grep. So if I do ls and I pipe it into grep -v T, it will find everything except these files that have T in them. And in fact, you see that it gives me everything else. So that's all for grep, and see you in the next lesson. In this very quick lesson, I want to talk to you about brace expansion, which is something that lets you create things very fast. With brace expansion, what you can do is to use curly braces in this way, 1, 2, 3, and as you can see, you get this output, and this is pretty straightforward. But the nice thing is that, let's say that now I want to add something here, like the name file. What happened is, as you can see, now things are getting interesting, and we get 1 file, 2 file, 3 file, and 7 file. So you can combine those in any way that you want. It's very helpful to create multiple files or folders if you want. Or you can do A, B, C _ file, and you create those without having to do that 3 times. Or create the file called example1 example 2, example 5, let's say you can go example and then 1, 2, 5, as you see. And a faster way to use multiple numbers is this one. You go 1 dot dot 7, for example, as you can see, or 1 dot dot 13, and as you can see we get up to 13. Just simply like that, you get all the numbers up to 13. Or if you want to start with 7, let's say, you get everything from 7 to 13. This works also with letters. If you want everything from A, let's say, to H, you go A dot dot H and you get all these letters. And for example, let's go inside folder 1. And if I want to create many files, I can do touch. If I want to create file 1 up to file 8, for example, I can go file and then brace expansion 1 up to 8. And now if you do ls, you can see that in 1 second we created 8 files. And in the same way you can create 80 or 100 files, okay, or folders. If we go make dir my folder underscore, then brace expansion from 4 up to 12, and you go ls, you see that we have all the folders from folder 4 up to folder 12. And the last thing that I want to show you, it's even a little bit more advanced. It's not something you use a lot, but it's nice to see. And it is that you can combine brace expansion. So if you go, for example, A, B, C, we know that we do that. If we want to add something like file, we have A file, B file, C file. But I can combine those and put here another brace expansion with numbers 1, 2, and 3. And now there will be the brace expansion A that will go with 1, and then it will go with 2 and with 3. And then there will be the brace expansion for B that will go with 1, 2, and 3, and so on, until we have all this combination, A1, A2, A3, and then B1, B2, B3, and then C1, C2, C3. And this can get as rich as you want. You can go A up to K, 1, 2, 3. So you have all this. Or you can go A and B, and 1 up to 5, and so on. So you can understand how rich this combination is, and how this shall let you perform powerful and quick creations of files or folders. Very good, see you in the next lesson. In this lesson we will talk about users and permissions. And we will do that because to run a bash script, this script must be an executable file and you have to have the permission to execute it. So the first thing that you have to know is that in every Unix system, so a Linux or system or a Mac system, there are different users. And different users can do different things. For example, right now I am in my Linux system, and if I want to know what user I am right now, I can use the command who am I, and it is gonna tell me what user I am right now. And as you can see, I am the user Fra. Okay, but there are different users, as I told you. And why is this important? This is important because every file in your Unix system is assigned to an owner and to a group. And an owner is the user that owns the file, and the group is just a collection of one or more users. So if I have a given file, how can I know what is the owner and what is the group to which this file is assigned? I can know that with the long list option of the ls command, so ls-l. The first name that you see here is the name of the owner of this file. So this file alex.txt is assigned to the user Pulse as the owner. The second name that you see here is the name of the group. So this file is alex.txt is assigned to this group. And so on for every file that you can see. For example, this file h2 is assigned to the owner Fra, which is me in this case right now. and is also assigned to the group that has the same name, fra. So now we know that there are different users in our Unix system, and every file is assigned to a user that is called the owner, and also to a group of users. And this is all well and good, but the question is, okay, but what can the owner do, and what can the user in the group do to this file? Can they do the same thing? Can they do different thing? Do they have the same permission? Before talking about the permission, we have to know what kind of permission a file have. And you have to know that in a Unix system, every file can be readable or not readable. And the readable is referred to the letter R. It can be writable or not writable, and this is referred to the letter W if this is writable. And it can be executable or not, and if it is executable, this is referred to with the letter X. Now, this is pretty straightforward what they mean. It is a file is readable if you can access it, if you can read it. A file is writable if you can modify it, so you can write in a sense to it. And a file is executable if you can execute it or if you can run it. Perfect. Now that we know all these three elements, we are able to understand everything about files and users. Because if we go back to the question, okay, this file is assigned to the owner Pulse and is assigned to the group plug dev, but what can the owner Pulse do to this file, and what can the users in plug dev do to these files? The answer is here. Now, the first character, you can ignore that. It's going to just be dash if this file is a regular file, and it is going to be a letter D if this file is a folder. What we're interested in is just this character here. And you have to look at this character in groups of 3. The first 3 characters, the second 3 characters, and the third 3 characters. Because the first 3 characters refers to the owner. And it tells you that the owner of this file can read the file, he can write the file, but he cannot execute it because, as you can see, there is no X here. The second 3 characters refer to the users in the group plugdev, and they're telling us that the users in the group plugdev can read the file, but they cannot write on the file because there is no W, and they cannot execute it because there is no X. And finally, the last 3 refers to everybody else, because if you are a user that is not the owner and does not belong to the group, what can you do? Well, this is what you can do. It is written on the last 3 characters. Everybody else can just read the file, but not write and not execute it. So in our particular case of bash scripting, we are not interested in the details of the permission. However, I wanted to give you the full perspective on that. But we're interested precisely in the permission to execute a file, because a bash script file has to be executable. Otherwise, you cannot execute it and you cannot use it at all. As you know, sometimes I want to show you that the Linux Unix system and the Mac Unix system are practically the same. So I want to show you, for example, that this is exactly the same thing again in a Mac Unix system. So we are in this folder, and if we want to know the owners and the permission of the files inside this folder, we will go ls-l and we get exactly the same thing. So for example, the file ab.txt is assigned to the owner Mark and is assigned to the group staff. And the owner Mark can read and write but not execute on the file, and the group can read but not execute and not write. And everybody else can just read it. So in the next lesson, we're going to very quickly see how we can make a file executable so we can use it. So in this lesson, we will see how we can change permission on every file. So let's see what we got here. As you can see, now we have this file info.txt. I created this file on purpose. This file has no permission at all. Nobody can do anything to this file. So for example, if I try to access this file to read the content of info, let's say for example with the cat command, I get permission denied. So the point is, how can I give, for example, to the owner, to the user Fra, permission to do something, for example, to read? We can do that with the change mode command. And it works like change mode, and then you give it a specification for the permission, and then you give the name of the file. So let's see how it works. We'll go change mode. And then if we want to give the permission to the main user, we will use the letter U and then equal what kind of permission we want to give. For example, let's say that we want to give the permission to read. Then we will go just U equal R and then the name of the file, info.txt. Right now, you can see that the owner, Fra, has permission to read. And in fact, if I try to access that this time, I can see that I can go inside and I can read what is inside this file. But still, I cannot write to it. If, for example, I try to append a line to this file, permission denied. Why is that? Because we don't have permission to write. So what we can do is we can give the main user, U, the permission to read and to write. In this case, you can see that we have both this permission. You can do that also with the group. If you want to give the group, for example, permission to read, you will go G equal R and then the name of the file. And right now you can see that the group has permission to read. And the same thing for everybody else or the other user. And the other user are referred to as an O, as in other. O equal, for example, let's say that we want to give other user permission to write and execute, but not to read, for example. We will go O equal WX. And we can check that right now. The other user has permission to write and execute, but not to read. Now, the change mode command is most useful when you want to give permission to execute a file, and we are interested in this in bash scripting. And a very fast way to give permission to execute a file is to use change mode and then to use the symbol +X to the file. And what this does, it adds the executable permission to everybody right away, so we don't have to worry about anything. So if I hit enter, right now you can see that this info.txt, everybody has permission to execute. In a similar way, if I want to take out the permission to execute, I will go -X. You can check that right now nobody has permission to execute. And of course, you can understand that this is working also for any kind of permission. So if I want to take out the permission to read to everybody, I would go -R. So there's no read permission anymore. So let's make it back readable and executable again to everybody. You can go change mode plus readable and executable. And this is very important because every time that you create a script, you have to remember to make it executable, otherwise it will not work. So very good, and see you in the next lesson. So in this lesson, we're going to see how to run our first bash script. So we are here in this empty folder. The first thing that you want to do is to create a file. Let's call it generically hello. So now we have this file here. What you want to do is to open this file and start writing on it. So you can do that with every editor that you want. If you are on a Linux system, I could suggest you to use gedit hello, and so you start typing whatever you want here. Now the first thing that you want to write into a shell script is a line that tells the system that this is something to be run by the bash shell, and you do that by using this symbol, the hash, the bang, and then the path of the bash program, and the path of the bash program is bin/bash. So this first line is just telling your program, hey, you want to interpret whatever you will find here in this file with the bash. Okay, that's just that. And then you can start writing your program. For example, we can hello everyone, and then goodbye, and then you save it. And when you save it, you will see that this first line is already working, is already letting the editor know that these lines are to be interpreted by the bash. And so when you see a keyword like echo, it puts that with this color. And the same goes for everything that goes within commas. While if I type whatever it is like this is nothing, so it will not color that for us. But if I write touch, for example, as you can see, as soon as I write touch, I get the red color because this is a keyword in the bash. So very good. We save it, we close it, and in order to run that, you press dot / and then the name of the file. But this time this is not going to work because we get permission denied. And why is that? Because as I told you, this file has not the permission to be executed by us, by the owner. So what we do, as we know, we use the change mode, adding the executable permission to this file. Now it is executable, and so we can run it. Dot / hello. And as you can see, it is running. If you want to edit it, you use the gedit editor or whatever editor that you want, open it, and then change it here. Goodbye. Let's say goodbye, people. Let's use a new line here. So we go echo -e, save, we run that again. As you can see, it's working. Now, what I want to tell you is that this is not strictly necessary, this line here. I can take that out, and the first thing you notice that as soon as I save without that line, everything's gonna get back to gray. But even without that, this is executable, and you can execute that. And why is that? Because by default, when you run a program, the terminal is gonna use the bash to run this. But what I want to tell you is that you want to avoid that. You always want to put here this first line that is telling the system to use the bash. And this is for two main reasons. The first reason is that when you start using more complicated scripts, the scripts are going to interact with each other. And many times you're going to use a script that it's running on Python or on Ruby or on whatever other programming language, and you always want to tell the system what program to use, okay? Otherwise it's going to be a mess. First reason. Second reason, you already saw why. Because as soon as you put this and you save, the program is going to understand whatever you write, and so everything is going to be much easier to do. So if I do mkdir, I now see that this is a keyword. So I can go my folder 1, and I know that I'm creating two folders, and it's pretty clear to see, okay? So I save, I run it, and if I go ls, you see that we created two folders. If I can tell you my favorite editor that works with everything in a very nice way and has a very broad capability, if you want to get more detail and advanced, is the editor Sublime that I can run with the command sub-l. As you can see, this is the editor that I'm going to use. It's extremely useful and clear, and I always use that. If you want to use that in a Linux system, you can just go and download this for your Linux system. If you want to use that for a Mac, there is also for a Mac, so it's very useful. So I want to show you that to create a bash script on a Mac system, again, is exactly the same thing. So if we want to skip this part, you're totally free to go. If you're interested, let me just show you. Let's create a file hello. Now I open this with Sublime, I go hash and bang, I save. Add the executable permission, and then run here, and then run it. Hello there. If I open again, and you can see that with this line, it does the same thing as the other editor. It understands when we have a keyword like this or whatever it is. So very good, and see you in the next lesson. In this lesson, we will learn about the if condition in Bash shell scripting. These conditions are incredibly useful and are used when you want to perform a certain command only if a certain condition is met. So if something happens, then you perform an action. If something else happens, then you want to perform a different action. So for example, if the user typed yes, you want to perform a certain action, and if the user instead typed no on the terminal, you want to perform a certain action, or probably you don't want to perform anything. So that was just to give you a simple example. Let's see in practice how we can do that. So let's create a script called conditions.sh. So let's say that we have some variable here that is the string hello, for example. Now let's say that we want to perform an action based on the value of d. So we can do that with the if condition. And we'll go if, and then the condition that we are interested in. So in this case, if the value of d, so $d, is equal to the string hello, semicolon, then, and this is the action that we want to perform. Let's say that in this case, we can write hello to you. And we close the condition with fi, which is the opposite of if. And also it's a good practice to wrap a string between commas like so. So now d is hello, and so this condition is fulfilled. And at the end, of course, the programs continue. The program continue. Let's also add a new line. So in this case, d is indeed hello, and so this condition is fulfilled, and so this action is performed. So if we run it, as you can see, this condition is fulfilled. But if d was not hello, but it was bye or whatever else, this condition would not be fulfilled, and we won't go inside this condition here. And as you can see, we don't get anything. Let's say that we want to perform an action both when this condition is fulfilled and also when this is not fulfilled. So if d is hello, you want to write that. Else, you want to do actually something else. And so you use the else command here. So for example, here you say, you write something like not hello. So in this case, this condition is not fulfilled, and so we get to the else part of the this if condition, and so this command will be executed, as you can see here. Now let's make it interactive. Let's add a read condition here. So we read in input a value that is stored inside a variable d. And now let's use this if condition here, and I get rid of the variable. So in this case, if I type hello, we get hello to you. If I type something else, we get not hello. Now, what if we are interested in matching multiple choices? For example, we want to do something if the variable is hello. We want to do something else if the variable is good morning. We want to do something else if the variable is bye. In this case, you can use the elif condition that stands for else if. So if this happens, you do that. Elif that again stands for else if this other condition happen, then you do that. And let's say, for example, that the other condition is if the, for example, is good morning, then we can write morning to you. And else if the is bye, semicolon, then something like by to you. And so if none of this condition above is fulfilled, else we can write something like have a nice day anyway. Let's run it. So we write hello, we get hello to you. If we write bye, we get bye to you. If we write good morning, we get morning to you. And if we write whatever, none of this condition is fulfilled, and so we get to the else part and we get have a nice day anyway. So this is the main structure of the if condition in the terminal: if, else, and elif. Now this if condition is divided into three main groups. The first group is what we have start looking at here, which are the if condition regarding strings. This here is a string. The second condition are if condition regarding numbers. And the third group is the if condition regarding files. Those are very similar, but they have different options, and I want to show you all the important ones of every group. So we started with the condition of the string, so let's continue with the option regarding strings. So the first option is pretty obvious, is what you saw. If a string is equal to another string, you use this syntax with double equal. So the first thing is the equal sign. The second thing that you can do is to check if a string is empty. And you can do that in the following way. You use the option -z. If this condition is fulfilled, it means that the string inside D is empty. Okay, so in this case you can do whatever you want. Let's just write empty string. Let's check this right away. And if I now just hit enter, so I create an empty string, as you can see, we get have a nice day anyway, because we are in the else condition, but also this condition is fulfilled, so we get empty string. So this is for the empty string. The other condition, which is the opposite of this one, is the non-empty string, and it is exactly the same of this structure. And in this case, the option that you want to use is -n. In this case, we have a non-empty string. So again, if I type something, we see that this condition is not fulfilled, and so we don't get this command empty string, but this is fulfilled this time. The last thing that I want to tell you that is true for condition on string, on numbers, and on files is the negation. When you want to negate a condition, and this is done by using the exclamation mark or the bang. So we saw that if we want to check if D is equal to hello, we have to go equal equal. If you want to say D different from hello, we take out one equal and we put this exclamation mark, and this symbol here means different. Okay. So if I write hello, we have this, and if I write anything else, we get into this condition not hello. Okay, because this string is not hello. This negation also works with option like this, -z or -n. And for example, this condition is met if the string is empty, and if I want to negate this condition, we can go exclamation mark space -z D. It means if D is not empty, then do something. And so in this case we can write not empty. Okay, so again we run. If I write something, we get inside this value. Last thing that I want to tell you before moving into condition on numbers and on files is to pay attention to spaces. The if condition is extremely important that you leave this space here and this space here. Whenever I forget to put the space here, like for example like this, and I save, if I run that and I write something, you get this error, because this is considered as a whole command. So you want to leave a space here, and this goes the same for this space. You want to leave a space here. So in this lesson we saw an extremely important aspect of bash scripting, which is the if condition, the else condition, the elif condition, and we saw how to apply that specifically to strings, to use the option on strings, and to use the negation in expressing conditions on strings. So very good, see you in the next lesson. In this lesson we will see conditions on numbers and conditions on files. Conditions on numbers are pretty straightforward. Let's start taking into input a number from the user, and then we can check a couple of things about this number. First, let me tell you that we're talking about integer numbers. So the first thing that we can check is that if this number is equal to a certain number. So for example, we have num here, and we could check if the value of num, so $num, is equal to, let's say, 18. In order to write the equal, you go option, so minus EQ, as in equal. Let's say that we check that is equal to 18. In this case, the syntax, of course, is the same, then it's 18. And we close the condition. And also we can add an else if it is not, so in this case we can write. In this case, this is not a string, it is a number, and so we don't need to wrap this variable between commas. So let's check this. Give me a number, 13, not 18. If instead we put 18, we get, yes, it is 18. If we want to check that the number is not equal to another number, we use the minus NE option. So here we use number not equal to 18. In this case, it is not 18. So let's save, let's run this again. If I type 13, as you can see, we get both this condition, of course, and this condition here. Instead, if it is 18, we just get it is 18. So this is number equal to 18 in this case. This is a number not equal to 18. Now we want to check a number lower than 18, and we do that with the LT option, standing for lower than. If the number is lower than 18, we can write lower than 18. So again, let's check this. If I write 12, it is lower than 18. If I write 19, of course it is not lower than 18, and this condition is not fulfilled. In a similar way, we have greater than 18, and this is done with the option G minus GT. So if we type 19 again, we get greater than 18. If you want the option of lower or equal to, there is the option LE, standing in lower or equal to 18. And the same goes for greater or equal to. And this is the option minus GE, greater or equal. This would stand for the symbol lower or equal, and this would stand for the symbol here, greater or equal. So for example, 15 is lower or equal to 18, but we can say also that 18 is lower or equal to 18. Okay, similarly here. So if we check this again and I type 12, it's lower than and lower or equal. If we type 34, it is greater and also greater or equal. But if I type 18 exactly, it is 18, and it is both lower or equal and greater or equal to 18, as we mentioned. So let's now see probably the most interesting if condition, that is on files, and let's take in input the name of the file and save it inside the variable myFile. Now there are many different interesting options with files that I'm going to tell you one by one, and for all of them the syntax is the same, so you can learn them very fast. The first thing that we want to know about a file, if this file exists, and in this case you use the option -e. So if -e and then the name of the file, my file. As usual, the syntax is the same, semicolon, then, and at this point we do whatever we want. For example, I write a file exists. So if I run conditions, for example, on this file ab.txt, we get that the file exists. But if I run this on something that I invent, we don't get anything. Of course, remember that you always can add an else condition. Now, the second important thing that you can check is if the file is a directory. And you do that with the option -d. In this case, the file exists and it is a directory. Pay attention that for all the following options, whenever you use them, you're not only checking the particular features, like in this case if it is directory, but first they also always check if the file exists. So this means that it exists and it is a directory. If instead you want to check that the file is a regular file, so what does it mean? For example, that it's not a directory, that is not a link, just a regular file, you use the option -f. And again, file exists and it is a regular file. If you want to check that the file has a length greater than 0, so it is not an empty file, you use the option -s. So let's check these three up to now, and then we move to something else. Again, in this folder we have all this stuff. Let's run conditions. Let's run our script. If we try, for example, this here, fold underscore, this is a folder, so let's see what we get. We get that the file exists, it is a directory, and it has length greater than 0. Let's run it on a file that is empty. For example, this one, cc is empty, as you can see, 0 byte. So we have the file cc.txt, and we get that the file exists. And as you can see, we don't get this output here. We don't get that it has length greater than 0. Why? Because it doesn't. Okay, let's move to the condition that let us understand about permissions. So we want to know if a file is readable, writable, or executable. Those are very handy. To check if a file is readable, you just have to use the option -r, as in readable. To check if it is writable, you just go option -w. And to check if it is executable, you just use the option -x. So we also can add an else condition in case they are not readable. And here we add the condition in case it is not writable. And here condition in case it's not executable. So let's check this. Again, we have all these files here. We run our program and let's check this file that, for example, is readable, writable, but it is not executable. So 123.txt and exists is a regular file, is readable, writable, but not executable, as you can check. Let's look at one that has all the permissions. So for example, this one, frank.sh, is readable, writable, and executable. Frank.sh is readable, writable, and oops, here we wrote writable instead. We should have done executable. Okay, let's run again. Frank.sh, this is readable, writable, and executable because the condition with the -x is fulfilled. Again, remember what I already told you, but I want to show you here in the case of files, the negation. Let's say, for example, that you want to use the negation on this condition here. If this happened, the file has length greater than 0. And if we want to negate this condition, just use the exclamation mark or the bang in front of this option. So if this is not the case, it means that the file exists and has length not greater than 0, which means equal to 0. So this is a useful condition, for example, to check if a file is empty. So let's check, for example, this file here that is empty, alex.txt. This is readable, writable, not executable, and as you can see, the file exists and has length equal to 0. So in this lesson, we understood how to work on if condition about files and the most important conditions that we can use with files. In the next lesson, we will see how to use logic operators and finally also a modern way to use the syntax for if conditions. So very good, and see you in the next lesson. In this lesson, we will talk about logic conditions. Logic conditions are a way to combine together conditions logically. So for example, let's say that here I have this number and I want to check if the number is greater than 3. But what if I want to check if the number was greater than 3 but also lower than 10? I should add an AND condition. And this condition is expressed with the option -a standing for AND. So that means I want the number to be greater than 3 and I also at the same time want the number to be lower than 10. Okay, so I add lower than 10. So I save, and in this case I know that, for example, 89 it is greater than 3 but it is not lower than 10. So if I run conditions, I don't get anything. If instead I use a number like 8, now we are in the right range. So if I run it, I get the output that the number is between 3 and 10. What if I wanted a number that is lower than 3 or greater than 10? So it is exactly outside this range. I can use in this case the OR condition. And the OR condition is expressed with the option -o. And we use that in the similar following way. The number is lower than 3 or the number is greater than 10. So 8, for example, is not lower than 3 and is not greater than 10. So we would not have anything of this condition. But if we put, for example, 12, now this condition is true. This number 12 is one of those two. It's true in this case. This one, if we put -7, again, this one will be true. We get the right output because this, in this case, this condition is fulfilled. So to recap, the AND option is an option that lets you verify if both conditions are fulfilled, and the OR lets you check if either one of the two conditions is fulfilled. Let me also give you an example of that with files. For example, let's say an example where I want a file that is executable and also non-empty. We remember that for a file to be not empty, we can use the -s option. If I want to check also if it is non-empty and executable, I can add -a as in AND, and then I put the executable flag. So -x, and again, the name of my file. So my file is non-empty and my file is executable. say that my file is the file frank.sh. Save. There is an error, and I'm glad that we made this error, because you can remember that you always have to put the space here. Let's save it and let's run again. And as you can see, we get it frank non-empty. Actually, the best output that we should put here is non-empty and executable. So we get the right answer. Frank is non-empty and also executable. And if you want to check that, we already saw that Frank is a non-empty file and it is executable. So this is how you combine conditions with logic expression like and, or, okay. The last thing that I want to show you is a modern way to use if conditions, and this modern way is pretty much the same as what we saw up until now. And as you can see, the only difference is that you have a double square brackets. The syntax for numbers is the same. For example, if number is lower than 10, then you do this. It's exactly the same with else or elif, exactly the same. And also for a file, it's the same. If you want to know if a file is non-empty, again, you do the same thing, option -s. The only difference are the symbol for and or. The and symbol, as in many other programming languages, is used with two of this symbol, and the or is expressed with two vertical bar or the two symbols for the pipe. So for example, if I want to check that the number is lower than 10 but also greater than, let's say, 2, I add double and here I put number is greater than 2. The number is 3. Let's do that, and as you can see, we get that our number is between 2 and 10. Similarly, if you want a number that is lower than 10 or greater than 20, you would go like that. The number is lower than 10 or the number is greater than 20, then you can write this. So let me put an echo here to clarify that we arrived at this part. Let's run this. And as you can see, we get that our number is lower than 10 or greater than 20. And just to show you a final example, if we want to use this condition with this modern expression, it's pretty much the same. We just have to replace this and option here with this and symbol here. So if the file is non-empty and the file is executable, just to show you that everything is working, as you can see, we get again that we have the right expression. So great, we finally have the comprehensive view on if condition, else, if on strings, on numbers, on files, and finally we also know how to use logic condition and how to use the modern version of the if condition. I will generally use the old syntax for the if conditions because I'm used to that, but it's important that now you know both of them, and so you can use whichever you prefer. So very good, and see you in the next lesson. In this lesson we will talk about for loops. A for loop is a way to repeat a piece of code as many times as you want. And as you can understand, this is really at the core of any programming language, because it lets you repeat a certain action any number of times, whether 1,000 times or 1,000,000 times. And that would be practically impossible to do manually. So this is extremely powerful. Let's see how we do that in bash scripting. So I have this script called loop.sh here. Let's write our first for loop. The syntax of a for loop is pretty simple. You go for, and then you use a variable, let's say I, for example, for I in, and then you choose a certain range. For example, 1, 2, 3, and 4. Semicolon, and then we type do. And what follows is the piece of code that you want to be repeated. So let's go simple and say, and you close the loop with done. So we save, let me put the window here so that you can see what's happening. And now we go loop. And as you can see, we get this line, hi there, repeated 1, 2, 3, 4 times. Of course, inside this for loop, the piece of code that you want to repeat can be as long as you want. We can add as many commands as we want. For example, I can add the ls command here. So let's save, let's run this. And as you can see, we have I there, and then the ls command is executed, and then hi there, and then it's executed again 4 times. Let's make this clear because it's not clear where the ls command starts. So let's add, for example, here the option -c to echo, and then we use new line, and then we put this, and then another new line. So now it's pretty clear that we have I there, and then ls command 4 times. So let's take this out. The very useful thing is that you can access the value of I inside a for loop. So you can write the value of I is, and you can access I. Save it and run. And here it is. The value of I is 1. Here is 2, here is 3, here is 4. And we will see that this is very useful. Also, you can go about the for loop not necessarily with numbers. I can go A, comma B, comma C, comma D. Now let me comment this part. And as you can see, we went inside this for loop 4 times, and the value of I is A, B, C, and D. Now you're ready to understand that you can put whatever you want here. So you can put a number 21 and then a string like my cat. The I will go in every and each one of this item, and this piece of code will be repeated for every and each one of this item, as you can see here. And to show you that you really can do anything inside a for loop and how you can use this for loop in bash scripting, let me show you that we can, for example, use this to create files. So we can use the touch command and create files with the name of the element inside the for loop. So for example, I create the file that is called $i, which is this variable of the loop variable, dot, for example, xls, an Excel file. Let me show you right now. These are the files that we have. If I run the script and I go ls, as you can see, we created all these files: 21.xl, mycat.xl, 1.xl, and so on and so forth. Let me remove those right now. Also, we can make use of brace expansion as we saw. So let me comment all this. So for example, we can go through the numbers from 3 up to 12. Or we can go through the letters from B up to F. And we can do everything that we do with brace expansion. For example, we can use this brace expansion to add also an underscore file here. And that would be, for example, a nice way to create many different files. And also we can use the more complex way to combine brace expansion, like from B to F, and combine that with the numbers from 1 up to 3. So we get all this combination of files: B1, B2, B3, C1 up to C3, D, E, F, from F1 up to F3. So that was for the brace expansion. Let me show you now a very important operation, which is the break. Break command is a command that lets you stop the for loop, because many times at a certain point you want to go out whenever something happens. So let me show you how you can go about that with the break command. Let's say that we are inside this for loop, and let's say that if for some reason we find some particular value, for example the value bad, let's say that we find that value, we want to stop the loop for whatever reason, then we can use an if condition, like so. If the value of I, so $i, is equal to this value, this string bad, then we want to break the loop. And then we close the condition. And let me also write that we're breaking the loop, breaking out of the loop. So in this case, the for loop will go to 21, my cat, 1, bad, but as soon as it go to bad, this if condition is triggered and this break stop the loop, so it will not go until end. Let me wrap this variable always around commas because we have strings. And as you can see, we get 21, my cat, 1, bad, and as soon as we go into bad, we break out of the loop and nothing else is accessed. On the other end, let me show you that if I comment this if condition inside, so it is no more present here, and I save and we run that again, as you can see, the loop goes smoothly through every element up until the end. Now, one of the most interesting features of for loop in bash scripting is running through files. To run through files, you simply tell the variable of the loop, in this case I, to loop through all the files in a particular directory. For example, let's say that we want to go through all the files in this present directory here. To go in the present directory, we know that we just type the dot, then a slash, and then we want to loop through all the files. So we use the star. So semicolon, do, and then echo, and then we can say the file is, and then $i. Done. Let's run this. As you can see, we are running through all the files inside our present working directory. In fact, if I do ls, you can check that these are all these files, and you can decide to, for example, use a loop only through the txt file. So you will go here, not every file, but star.txt. So let me copy this and let me use that with the txt file. As you can see now, the first loop is through all files, and the second loop is only through the txt files. And this is incredibly powerful because now at this point I can, for example, remove this particular file or change its name or get information about these files. I literally can do whatever I want, moving through every and each file in my whole system. It just depends on where you want to go and what you want to do inside this very simple for loop here. And also let me tell you that we always used the letter I to go through a loop, but you really can use whatever letter you want. For example, if we take this loop here, you can use the name, I don't know, my nice file. Okay, for my nice file inside this file here, echo the file is, and of course now we have to access that with $, my nice file. Okay, this is now the variable that is looping through all the value here. So let me write this in capital letters so you see a difference. My files are, and here it is, my files are, and everything is working properly. Okay, last thing that I want to tell you is a modern syntax to use with the for loop when you want to use a for loop just with numbers. Okay, and it works like that. It goes with 2 round brackets, and then the first thing is that this is the starting value of I. Then you have the last value of I that you want to get to, and then you write the increment of I. In this case, you want to increment I of 1. So in this case, we are just printing out all the value from 0 up to 24. And as you can see, we go from 0, 1, 2, 3 up to 24. This has 2 advantages. The first advantage is a way of having clear that you're using a for loop in numbers and what is the starting number, what is the ending number. But I think that the most interesting part of this modern way is that it lets you use an increment that you choose. For example, let's say that we don't want to move of just 1, but we want to move in steps of 3, for example. I just have to type that I is equal to I plus 3. And now, as you can see, I will move from 0, not to 1, but to 3, and from 3 to 6, and so on. And as you can see, we have 0, 3, 6, and so on, moving in steps of 3. If you somehow have to deal with numbers, this modern way may very well come in handy. So very good, we saw a very important feature of the bash scripting, for loops, and we saw for loops in a very simple way, and we saw how we can move through whatever kind of element that we want, how we can use brace expansion in for loop, and how we can break out of a loop if something that we don't want is happening. Also, we gave a particular attention to for loop in files. And lastly, we saw the modern syntax for using a for loop with numbers and how we can take advantage of that. In this lesson, I'm going to show you the script that we will be creating. So the thing is, let's say that we are inside a folder like this, pwd, we are inside classes. And this is a very nested folder, as you can see. Now, many times what you have to do is to go from classes to a folder up, like, for example, A or target. So what you do is you start doing cd ... and then you moved up one folder, and then you have to do that again and again and again until you are in folder A, for example. Or another thing that you could do is, let's move back here. Another thing that you could do is to do that here, cd ... slash, and then ... slash, and then again and again, like so. So this is very time consuming and bothering when you have to work a lot inside these folders. Maybe you have to spend some time here, and then you have to go back to A, and then you have to go back, for example, here, and then go back here. So the script that I'm going to show you, what this script does is, let's say again that we are inside this nested folder classes, and let's say that we want to go 4 folders up, 1, 2, 3, and 4. So here, the script back lets you do that as simply as that, back 4, and you can check it with pwd. This is an example of a script that is very simple and yet very powerful for two main reasons. The first reason is that this is actually an helpful script that, for example, I use on a daily basis. Sometimes I also use that inside other script. So this is really a simple yet real-world example of a script. The second reason is that, however simple to do this script as our first script, we will have to face anyway some slightly tricky parts of bash scripting that I really want you to learn. And so this is actually what we are going to learn. So be prepared, and let's move on to the next lessons. In this lesson, I'm going to talk to you about the bash shell, and in particular about subshells and what happened in subshell. Now, when we open the terminal, what happened is that the bash command is executed and our shell is open, and now I can do whatever I want in this shell, which is also called a born again shell. That is why the name BASH, born again shell, a new version of the old shell, which was SH, the normal shell. Now inside our shell, we know that we can do everything. We can type command like ls, we can assign variable like a equal 32. And inside this shell, if I echo out the value of this variable, I'm gonna get its value. Also, of course, I can go out from this shell, and I can do that via the command exit. If I do that, I'm gonna go out this shell. So if I hit enter, as you can see, and now I cannot do anything anymore because I went out of this shell. If I want to go back in this case, I have to start the terminal again. Of course, if I start that again, the value of A is not saved, so I won't get anything. Now, the nice thing is that I can use the bash command to open another shell with the bash command. If I now type the bash command here and I hit enter, what happened is that we enter in another shell that is usually called a sub shell. If I hit enter, now I am inside the sub shell. Now, how can you tell that? Now, it seems that nothing changed, but let me show you something. If I now type exit, what happened is that we will exit the sub shell, not the current shell. And so nothing will be shut down. We will just go back to where we were. And in fact, if I hit enter, as you can see, we exit the sub shell, nothing happened. We are back to where we were. Another thing that I want to show you very important is this. Let's go back inside bash and let me set the variable 104. So if I do echo $B, of course, I get its value. Now, if I exit this subshell, I hit enter, I am back in the current shell. What do you think is going to happen if I try to access B? Now, B was set in the subshell, so the current shell does not know anything about this value. In fact, if I hit enter, I don't get anything. To give you a clear picture of what it means to be in a subshell, the easiest thing is to think as if you were to, for example, open another window. Here we are in another shell. We can do everything that we want. If I set the variable here, of course, this is not going to happen here. Okay, so this is the meaning of being in another shell. And let me show you another way to make this very clear. Now we are in the current shell here. Let's go inside the bash. Let's go inside the subshell with bash. Now let me go inside, for example, library. So here I am inside library. I do all of this. Now what happened if I type exit? Well, if you remember, in the current shell, I was not in library. In the current shell, I was in my home folder MacBook. So what happened if I type exit now is that I will go back to where I was in the current shell. And in fact, if I hit enter, you see that I go back to my home folder. Now, what you can do inside the subshell is, of course, the same thing that you can do in a current shell. So if I go, for example, inside the subshell like this, and then we go in some script, here are all our files. Of course, if I create a file with a touch command, like let's call it subfile. Now I have subfile. And of course, if I exit this subshell, and now as you can see, I am back in the current shell. Of course, if I check the content of some script, I go ls, subfile is there. Okay. So whatever you do in the subshell stays, of course, the same in the current shell. The directory where this command bash is present, we can know that with the which command. So I go which bash, and we know that it's present inside the bin folder. And as for every other command, we can execute the bash command using the absolute path. So if I type like so, I get inside bash, and then I can get out, as we now know. Now, why did I tell you that? Because in this way you can understand something very important and useful about our script. Because let's now open a script. When you open a script like this, you can understand that what the first line is doing is actually calling the bash command. So what it's doing is actually entering in a sub shell. So for example, let's go hello. Let's go echo hello. And let's set the variable d equal 123. And let's echo this variable out. D is d. I get this, but you can understand now what happened if I try to access the value of d. Will we have the value of d 123 or not? This is done inside the subshell. So here instead, in this blue screen, we are in the current shell, and the current shell does not know about the variable in a subshell. So if I hit enter, in fact, I don't get anything. And also, for example, if let's say I type echo last line here, if I type exit here, that is a very useful command to go out from the script. What happens is that when the file reach this point, the exit command will let us out the subshell, not the main shell. That is why when we get exit here, we don't stop the current shell, we just stop this. So what happens if I do that and I go script, you see that this line is not run, but we didn't exit the current shell. So now the question is, how can we run a script like that, not in a subshell, but in the current shell? And the answer to that is the source command. And we're gonna see the source command in the next lesson. So let's see the source command in action. Let me show you this. Let me take out exit, let me save. If instead of running script like so, I use the source command, the source command forces this script, this command, to be run in the current shell. So now I do source script, I run it. Of course the output is the same, but now what happened if I try to access the variable d? What do you think? The last time we didn't get anything. But now with the source, what the source command did, it forces this to be run in the current shell. So the current shell knows that d is 123. In fact, if I hit enter, we get 123. Just to give you a more extreme example of that, if I now use the exit command here, and I save, and now instead of running script, I source script, what will happen? We'll get to this point, and now the exit command will be run inside the current shell. So we will go out from the current shell. Let me clear the screen. I go source script. You can see that right now. And as you can see, I get the output up to 123, up to d is 123, and then the exit command let me exit from the current shell. So let me close and open another window. The last thing that I want to tell you is that the source command can also be used with the dot. So instead of source script.sh, we can run dot script.sh. I don't particularly like to use this command because it's not very clear, and the dot has a lot of use in the terminal, so I prefer to be very clear and always use source. But just to let you know that I can use that in the same way as source. The last thing that I want to show you is that you can go inside as many subshell as you want. So for example, I'm here, let me go inside some scripts, and I can enter another subshell. So now I am inside another subshell, and I can enter another subshell. So now I am in another subshell, and I can enter another subshell, and so on. So now what happened is that I am inside a subshell that is inside a subshell that is inside a subshell that is this one that is contained in our current shell. So the red one is the current shell. So what happened now, if I do exit, I go from this one to this one. And if I do exit again, I go from this one to this one. And if I do exit again for the third time, I will go back to the current shell. So let me show you that. I go exit and I am out one subshell. I go exit again and I'm out our subshell, and I go exit again, and finally I am in my current shell. In fact, if I go exit, I go out. So in this lesson you learn about the current shell and the subshell and the difference between those, and also the fact that when you run a program, this will of course going to be run inside the subshell. And finally you learn a way to have this program run in the current shell and not in the subshell, which is the command source. So very good, and let's move to the next lesson. So in this lesson I'm going to talk to you about the different kind of commands that we can find in the shell. The first kind of command is an executable program. And for example, commands like cat, or for example, scripts that we create ourselves. So for example, if we now create a script that is called our script, this script will belong to the category of commands that are executable program, in the same way as cat or ls are commands that are executable programs. Okay, so this is the first kind of commands that you have. The second kind of command that you have are shell built-ins, and these are commands that are built into the shell itself. A command like cd is a shell built-in. Okay, and the third kind of command that we can encounter is an alias, and this is what we're going to talk about in more details, because we're going to use that in our script. And an alias is a command that we can define ourselves, built from other commands. Okay, so there is a way to know what kind of command we are dealing with, and we do that with the command type. So for example, if I go type cat, I get that cat is in bean cat. This is a way to tell us that cat is an executable program, and in particular it is contained here. Okay, if I do instead type cd, I get the cd is a shell built-in. And finally, if I do type lf, which does not exist, I created this, it is an alias, I get lf is aliased, and it also tells me what it does. So lf is the same of the command ls with the option -flha. And if I take a script that I create myself, so for example script.sh, this is the same as every other executable program, so I get the script.sh is here, and so it is again a way of telling me that this is an executable program. And just to finish that, type itself is a shell built-in. So in the next lesson we're gonna go in detail, we're gonna go a little bit in detail about the alias program, because we're going to use that for our script. If you already know how to use the alias command and how to make command permanent in your system, you can skip that. If you don't know about that, or you have some doubts about the alias program, you can jump right into the next lesson right now. In this lesson we're gonna see aliases. An alias is simply a command that we create ourselves. So the basic example is when we type ls, many times we use ls -l. So we can create a shortcut or an alias for the command ls -l. And the syntax is the following. We write alias and space, and then the name that we want to give to our command. For example, we could call it ll, then equal, and then quotes, and then between quotes we put the command that we want to execute, for example ls -l. So now every time that I type ll, this will act as this command here. If I press enter, you can see this is working. Another example might be the case where we don't want to list the content of this folder, but we want to list the content of the parent folder, the folder that contains our folder. So usually we would do ls ... and so we can create an alias for that. So we can go alias. And now another thing that I want to tell you is that you can call your command whatever you want. So for example, I can call it yellow. Okay, that would not make much sense, but it's just to prove, just to show you the point. So yellow would be ls and ... And now whenever I press yellow or even yell, I can press tab and it is going to recognize my command. So it's going to autocomplete that. So I hit enter and this works. So now yellow and ll are my aliases command, and I can check that with the command type. If I do type yellow, I see that yellow is an alias to ls dot dot, for example. Another way to know what yellow is, once we know that a particular command is an alias, we can check the content of the command using alias itself. So I can go alias and then yellow, and I get that yellow is this alias here. A slightly more articulated way to use an alias is with semicolon. We saw that we can use commands one after the other, like so, for example. So we get ls, and then the command cd is executed, and we went inside the home folder, and then we get the string hello from echo. And of course we can take advantage of this in an alias command. So for example, many times while I'm working, I always do the same thing. I clear the screen, I ask for the present working directory, and then I list the content of the folder that I'm in, just to check that everything is as I expect. So I go clear, and then I go pwd, and then I go ls-l. So I take advantage of the alias command, and I create an alias command which I called cpl, and this command will clear the screen and then give me the present working directory, and then do ls-l. And also before that, just not to confuse this to output, I echo out a string like so. So now if I go cpl and I hit enter, I have everything. My screen was cleared, I have the present working directory, and clearly separated from that the list of all the file inside with one command. How do we know all the aliases that we create? In order to know them, we just have to press alias. We hit enter, and we get a list of all the aliases that we have. And these are the last one that we created, like ll or yellow or cpl. What if now we want to get rid of an alias? Let's say that, of course, I want to get rid of this yellow thing here. So we just use the command unalias, un alias, and then yellow. And now if I press yellow, I don't get anything. And you also can check it from here. There's no yellow alias anymore. Now let me show you another thing to put together the concept that we saw in a previous lesson. If we now enter another bash, do you think that we're gonna get this alias here, for example, the cpl command? Of course we don't, because we are in another shell. We are in a subshell, okay? So they're nowhere to be found. But if I exit, of course, and I go back in this way to the current shell, again, now this is gonna work. The same thing goes now if I go exit. If I exit this shell, or if I just close this window here and I reopen it, the cpl command is gone. It was erased. So how do we save the aliases that we want to use every time? Of course, we go inside our login script. In this case, again, is .profile. It's always a good case to add a comment of what we're doing, because we have to be able to read it at any time, even 1 year from now, and other people have to be able to read it. So we just write that we're adding an alias. This is pretty straightforward, but it is always a good practice. And so we go alias. Let's also add the A option so we see the hidden files. So now I save, I source our .profile. Of course, now I have the cpl running properly, And even if I close and I reopen it, you'll see that the cpl command is still running properly, is still our alias. So in this lesson you saw a way how to combine commands that are useful together and create a more powerful command thanks to the alias. And you also saw how you can make that new alias command permanent by simply adding it to your login script. So let's move now to the next lesson. In this lesson we're going to talk about command substitution or command expansion. Now the question that brings us to command expansion is the following. How do we use the output of a command? For example, if we want to know the path for, let's say, the cd command, we know that we go which cd, and now I know that this is the path of the cd command. Now let's say that I want to have a clear listing of this command here. What I would do would be ls -l, and then I would copy this manually and paste it here and hit enter, and I would get this result. Now what I can do instead is use command substitution, or sometimes also called command expansion. Now how does this work? This works simply in this way. If we want to use the output of a command, we use the following syntax: $, round bracket, and inside that we use our command. So for example, in this case, what we could have done, instead of manually copying and pasting the output of the which cd command, was to just do ls -l, and then here put the output of the which cd command. So just go $, and then our command, which cd. And as you can see, we get the desired result. Another extremely useful way to use the command substitution is for storing the output of a command inside a variable. So let's say, for example, right now we are in this nested folder Alex, and I want to save this whole path inside a variable because maybe I want to use this path later on. So what I can do is to go a equal and then use the command expansion of the command pwd. And so right now inside a, I'll get this path, as you can see here. Now of course you could do that manually, like copy this and paste it here, but first of all that'd be error prone, and the second and most important thing is that we are dealing with bash scripting, and in bash scripting you cannot do things manually. You have to run a program, a bash program, and this is something that we will use extensively. Now as a last thing, I really want you to grasp the following slight difference when we're using command expansion. So let's say that we use the command date that gives us the time, for example here 12:30. Now let's say that I save the output of the command date in the variable d. So I go like this. So I hit enter. Now if I enter the value of d, I get 12:30:59. So the command was executed, the value was put inside d, and I get this. Now I want you to focus on the difference between these two values, $d and the command expansion of date. What is the difference? Is there any difference at all between these two? Because as you can see, d is exactly $date. So someone might think that these two commands are the same, but actually this is not the case, as you will see here. This is 12:30:59 and this is 12:31:51. So why is that? This is because when you run this program, when you run this command here, the output of the command was given to the value of d once and for all. Now d will be forever 12:30:59, while whenever you execute this command expansion, what the terminal does is actually executing that command at that very moment. So at that moment, time was 12:31:51. Now we learned all the pieces that we needed to face our script. And so in the next lesson, we're going to create our first simple real-world Bash script program. In this lesson, we will see how to use scripts with parameters. We already know that every command in our terminal is an executable script like the ls command. And we know that it can work on its own, for example, like that, or it can take parameters like the name of a file, for example, like this, or options like in this case. And an option for a command actually is just a parameter that we pass to the executable shell script of the ls command in this case. So we get a different output using this parameter. Now, how can we use parameters in our shell script? This is pretty straightforward. Let's open a shell script that I prepared here. We can access the first parameter that we give to our script just by the symbol $1. So for example, let's write, this is parameter 1, and we write $1. Let's save it and run the script. We don't get anything because we didn't give any parameter to it, but if I gave something, you can see that we have our first parameter here. And this goes for as many parameters as you want. So this is parameter 2, and we can access it with $2, and so on and so forth for the other parameters. So in this case, we will have, if we run our program with different parameters like this one or this one, or even numbers, that we have all this kind of parameters. And of course, if we don't put all of them, we will have empty spaces. You can also add parameter as strings with empty spaces, but we will have to use commas for that, like this one parameter. And the last thing that I want to tell you is that you have to pay extra careful attention if you want to use a number for a parameter that goes beyond 9. So if you want, for example, to access parameter 12 and you try and do this, this will be wrong. As you can see here, if we add many number of parameters, you'll see that as parameter 12 we get Q2. And this is because when you try to access this $1, 2 will interpret $1 as this parameter here. It will access this variable here, and in our case the first variable is Q, and then 2 will be just interpreted as a string that we add to this. So the right way to access parameter 12 is to use the proper variable expansion, and so to use curly braces in this way. And in our case, the 12th parameter is 1, 2, 3, 10, 11, 12 is the U. So if we do that again, we get the right answer. Now, what if we want to count in our script how many parameters we have? There is a shortcut to do that, and this is by using the $hash. This is the number of parameters. In this case, we have 12 parameters. And of course, this works with any number. A very useful way to access all the parameters is via the symbol $at. This will access all our parameters, as you can see here, all parameters. And this is useful if used in a for loop, for example, to run over all our parameters. So if we do a for loop for I in $at do, and as you can see, we have a for loop that goes through all of our parameters. Now, this is true that you can also use this other symbol here, the $* standing for every parameter, and also in here this does exactly the same thing, as you can see, but these symbols differs when they are used inside commas. So this symbol is different from this symbol here. In fact, If we do this now, what happened is that this symbol here with commas will be interpreted as all the parameter as just one whole thing, one whole parameter, one whole string, if you will. So in this case, if I run this, you can see that in the for loop there is just one item. It just looped once because it considered this as just one element. This is not the case if you use the $@ so this is more convenient usually to use this symbol instead. If I save it and run this in this way, as you can see, again we get a loop over all of our parameters. So in this lesson we're going to create our back script. So what we're going to do is when we are inside a folder like this, we want to be able to do a script that goes back as many times as we want. So the command that we want to use is the command cd ... and we want to use that. In this case, if we use that once, we go back once. If we use that twice, we go back twice, and so on. So let me move back to my folder and let me open our script. And let's do that. So what we want to do is to first of all save the number that I will give as a parameter to our script back. I call that max. And then what we want to do is to repeat the command cd ... and so we use a for loop. Now let me show you something. We know that in a for loop, if we use a syntax like this, we can use like 1 ... 5 and then echo I, and this is going to of course run a for loop of 5 elements. So we might want to try to put as the last element max, but this syntax is not good for that. In fact, if you try and use that, this is not going to work. So this is, for example, why you want to use syntax like that instead, the arithmetic, let's say, kind of syntax. So for I equals 0, let's say minus max. Now it is clear that I can put a variable here. There's no problem in that. So let's try again. Let's see again that everything is working fine in this case. Minus equal to max. Next 7 should print element up to 7. Here it is. So now what we want to do is we want to do cd ... and we save, and at the end let's echo out present directory is this one, and we expand the command pwd. So we are in here. Let's say that we want to go up to folder 1 and 2. We want to go to user, so let's use back 2, and we see that we are not in user, but we are in one folder. We moved one folder too far, so we arrived to the root folder. So we actually want to move not when I is less or equal than max, but just I less than max. So let's do that again. Let me show you where pwd again here, back 2, and now we are in fact 1 and 2 in users. Now, what is the problem that you might have noticed by now? I'm not sure. This is telling the exact final destination, but if you check where we are now, if I do pwd, we are not inside user, we are still where we started. And why is that? This is a very nice example of what I told you about. When you invoke this command, you open a new bash, and when you open a new bash, this is a sub shell of this one. So we have this one, and we use bash, and we go into a sub shell. So whatever we do here is not done in the interactive shell. So in the sub shell, I am actually inside user, and you can see with this command. But here, this did not happen. Now, usually this is not a problem for almost every script that you want to do, because in every script what you want to do is you move inside your files and folders, you edit them, you remove them, you do whatever you want to them. And if you do that in a sub shell or in a shell, it doesn't matter. What you want to do is to do things, mess around, do whatever you want with your files, okay? But in this particular case, this script is a script that want to work with the present shell, with the primary shell, not with the subshell, because I want to go back to folder in my present shell, not here, not in a subshell, okay? So this is where the source command come in handy. So this script is nice as it is, but what we want to do is we want to run the back script in this way with source back 2, and now you're going to see that this is going to work. So as you can see now, if I do pwd, I actually am inside user. This worked because source forced the script to be run in the present shell. The only shortcoming of this is that you usually don't want to run program with the source command. You want to run program like every other program, like back, you want to run back in this way. You don't want to have a special treatment for some script and a different treatment for other script, okay? This can get things messy. So what we can do in this case is to use an alias. So we do alias back equal source back. Now whenever we invoke back, actually we are running source back, and this is going to work. Now as you know, if we do that in this way, as soon as I close this window, as soon as I reopen my computer, this alias will vanish. We know how we can solve this problem. We just go inside our login script of our terminal. In this case is my .profile. I open .profile, and here let me write alias for back script, for the back script, and we added alias back equal source back. Now we save. We know that this is not going to work right now. We have to actually source the .profile file. So we're gonna source .profile, or if you don't want to do that, you just can close the window and reopen it, and this is gonna source the .profile on its own. So we do that. This worked. Let me clear the screen. Let me go inside the nested folder. Like I went again inside classes. I didn't show you because it takes so long to get into this nested folder. So I'm here inside here again. Let me go 1, 2, 3 folder back. So in target. So I go back 3 and pwd. I really am in target. So let me just clear the echo command here. So as you saw, this very simple program is, I think it's pretty powerful because it shows you some tricky aspects of the shell, like the fact that when you run this, you're in a subshell and you have to take that into account. You cannot use a command like cd and hope that something is going to happen here. The second thing is that if you want to run a for and you have a number that you want to give as an input, this kind of syntax with the curly braces might not be the best one. As a third thing, you saw a use of alias that was not just a nice shortcut to have. It was quite necessary, I would say, because when you start using scripts within other scripts, what happens is that you don't know which script need to be sourced and which script need not to be sourced. So you can really start getting errors with bigger scripts and you don't know what's happening. So if instead right after you create the script, you create the alias, now you're making this script behaving in the same way as every other script and you avoid any possible problem. That was the third thing. The fourth thing is that you saw, I would say very simply, a use of source which is not theoretical but was really a practical use of source. And hopefully now you understand the importance of this command and what is the difference of this command rather than simply executing a command. and you can bring that with you whenever you will do your own scripts. And finally, as a bonus, I would say this script is really a script that you can use in your everyday use of the terminal. I actually do that because when you're in folder like this one, so nested, and you have to go back and forth many times, this is really the way you probably would go. So I hope you followed up to this point so you're ready to get to the next script. So in this lesson, we want to see where can we run our scripts and how can we make those scripts executable everywhere in a terminal. Because you see right now, for example, I am in this some script folder and I have these two executables. So if I run the script hello, I get hello, this is my script, bye bye. But if I go anywhere that is not this folder, for example, we go in even our home folder and I try to make this script work, I cannot do that. I have to access some folder. So I have to go dot some script and then hello. And now we'll go. Now, as I explained to you, every command in the terminal is just an executable script. So when I do man, for example, this is a command that actually is an executable script. But why is that that I can run man without being in the folder where this command is? Or any other program, for example, I have Python 3, it will run. The reason for that is that all these programs are saved into the path variable. For example, if you can see here, we have the folder where the Python program is saved. And what the system does when we log in the terminal, and what the terminal does is when you type anything on the command line, it will look for this program inside any of these folders. And if it can find it, it will execute it. If, as in this case, it doesn't find it, it will tell us command not found. For example, Python 3 is inside this folder here. And in fact, I can even ask the terminal to tell me in which folder exactly. So I go like this, and as you can see, we have this. So just to show you, if I go cd and I go inside this folder, so right now I am inside this folder, and I go ls, you see that here I have the program Python 3. So now it should be clear how can we make our file executable. So if we go again inside some scripts, what we have to do is to take this folder here, the path of the folder, so user, in this case, user MacBook some script, and add it to the path. So to do this, let's take a look at the path variable. Path variable is just a list of path folders that are separated, and this is important, they're separated by a column. So there is a path, then a column, another path, and then a column, etc. So what we have to do is just add this string to this path variable, separating it with a column. And we know how to do that manipulating variables. So for example, you remember that if I go var and I call it the variable ABC, if I want to add something to this variable, I can do something like that. Var equal whatever you want. So new line, and then $sign var. In this way, I will add this string to the string contained inside var. And in fact, if I now echo var, you see that I have new line and then ABC. And I can keep on doing that with anything that I want. So for example, here I can add the line ABC underscore semicolon, for example. Now we have ABC underscore column and then the rest. And we can keep on doing that anytime that we want. So what we have to do is just to add this string in this way that I showed you in the path. How do we do that? We go, of course, inside the login script as I showed you earlier in the course. So let me copy this. Let me go in the home folder. And let me open our login script, which in the case of the Mac is the dot profile. Here we are. You can do that wherever you want. I usually have a place where I add path, like this one. What you do is exactly what I showed you with variable. Path is a variable, so I type the variable path equal. I add the string that I want to, so this one. And then remember to add a column to separate this from the rest. And then I put again the variable path. And the only thing that you want to do to be more precise is to add the command export path that will ensure you to have this variable working right away. Now I save it, close it, we source the file, or you can just close and reopen this. And now look at what happened. If I type hello here, I can also use the completion tab, it works, and I hit enter, it works. And it works wherever you are. You can go wherever you want. Like let me go in desktop. I'm inside the desktop and I have all the stuff and I want to run my script. Hello. Here it is. I want to run, what other script did we have? We have the script name. I want to run name. Here it is. What's your name? Da da da, etc. etc. Now you can run your script wherever you want in the same way as you can run this command, or you can run this command, or you can run whatever command in the terminal. Every command in the Linux system has an exit status. This exit status is a number, an integer number, and it is 0 if the command was executed successfully, and non-zero if the command was not executed successfully. So, for example, if I type pwd, this is a successfully executed command. If I want to access the exit status of this command, I can use the dollar and question mark symbol. So I will go echo $, and question mark, and I'll get the exit status of this, which should be 0 since everything was fine. And in fact, I get 0. If I do something like pwd and then I add some non-existent option, and in fact I get some problem, now the exit status cannot be 0. And in fact, in this case is 1. Same goes if I write or I misspell command. The exit status is, as you can see, different from zeros. And now that we are in a little bit more advanced section of our course, I can tell you that in the manual page that every command has its exit status described in the manual page. So if I go, for example, man pwd and we look for the exit status, we see here exit status pw utility exit 0 on a success and greater than 0 if an error occurs. And some of the commands have more detailed explanation on their exit status. For example, if we look for grep, here it is. Exit status, the grep utility exit with one of the following: 0 if one or more lines were selected, were found, actually it means, and 1 if no lines were found, and greater than 1 if an error occurred. So, for example, let's see here, we have this file, new3. Let's see what it is inside. You have this file and we have this string end here. So if I were to use the command grep here and looking for the line end, I find this string end, and in fact I get an exit status of 0. But if I, for example, look for a string that is not there, I don't get anything, and I get an exit status of 1, as the manual page said. And finally, if I look for something in a file that is not there, I get an error, and I get an exit status of 2. These exit status are important mainly in shell scripting, because you can take some sort of action in case you get some problem with some commands that you're running. And we're going to see some example of those in the section about function of shell scripting. Sometimes you might find yourself, when you use big shell scripts, to use the same chunk of code many times and maybe with different input. In order to properly use this chunk of codes many times, you can use functions. Now, a function is a small chunk of code that you can use as many times as you want in your script without having to copying and paste all the time this chunk of code. And so it is useful when you need to perform a certain action multiple times. And you'll see that the more you use the shell script, the more you will use function. Programmers use function on a daily basis in their script in any kind of programming language, from C, Python, C++, whatever programming language. Almost all of them, they have function. So let's see how we can use functions in shell scripting. So let's say, for example, that I have this simple chunk of code here. Right, today is, then it gives me the date with the common date, and then tells me have a nice day. So I start here, and then I have this chunk of code here, and then I continue here. So that would be something like this. Now, if I want to have a function that do this instead, because maybe I have to do that many times, I can do the following thing. I write the name of the function, that can be whatever I want it to be. So for example, my date. Then I use 2 round brackets, and then I put the function inside curly brackets. So I put this here. Save. Now, instead of this, I can put my date. And this will do exactly this. Let's change it so that you see that we are actually doing that. Have a great day. And if we run this now, you see that starts here. Today is have a great day. So here this command called this function here, and it was performed. Now, a nice thing about function is that they can have input value. So for example, let's say that I want to do a function that says hello to 2 people. So I build the hello function, hello to functions. So 2 round brackets, and inside curly brackets I do this, hello. Now here I want to put the first variable that I will give as input to the function hello2. So I will write $1. $1 refers to the first input value that will be given to hello2. And then if I have another value, I can use it as well. Hello also to $2. If now I use hello2, I can give as input whatever I want. So for example, the string mark and the string blah blah blah, and I save it. Now what happens is that the function of hello2 is called, and this will be given as an input of this, and this will be given as the second input and will be used instead of $2. So we save it, we run it, and you can see that we have the function is called, and we have hello, $1 is this, so mark, and hello also to blah blah. So we saw that the terminal commands has returning values, and there 0 is if everything is okay, and non-zero if something was not okay, and the same goes for functions. So for example, here I can write the return value of my function is, and you remember that the returning value is given with a $sign and question mark. So we will have the returning value of this function hello, and we see that the return value of my function is 0 because everything was okay. The nice thing about function is that you can also change the returning value of a function by simply typing whatever returning value you need to give to your function. So for example, here you would just type return for, I don't know, 35. So now if we save and we run it, we have that the returning value of the function, as you can see, is 35. And it can also be very useful to have different returning values depending to what is happening inside a function. So for example, let's say that in a particular case, if something happened, I want a 0, and if something else happened, I want 1 or 2, I can just put an if else within the function. And if something happened, I give a returning value, and else I give another returning value. That could be very useful. In this lesson, we see the scope of variables within a function. Let's take a very simple and stupid function, like I assign the string x to the variable 1 and the string salad to the variable 2, and then I print out the value of the variable 1. My variable inside the function is this. Now we start the program, and then I call my function. And then, of course, we will have my variable inside the function is x. If I now echo out the value of var1, let's say outside, and I do var1, what happens is that the program will remember this value even if we are outside. This is very typical of shell scripting in a terminal. This is very different from other programming language. So if I save and I run it, you see that outside is still x. This is because these variables are called global variables. If you don't specify anything, every variable in shell scripting is a global variable. So it means that their scope is not only within the function, but it is also outside the function. So you can access the value of this variable wherever you want. If instead you want a variable to be just local, to have a local scope only within the function, you want to add this command, local, and then you use the variable. Let's make the variable 2 also local. Now, if we save and if we run it, the variable 1 and 2, their scope is just within the function. So outside the function, they will not be found. So you won't see anything here. Let's check it. And you see that my variable inside is x, and outside we don't get anything. If we instead we leave variable 2 as this, and we print variable 2, you will see that the variable 1 is not seen because it is local. This is empty. But variable 2 is global, so it's seen also outside. Now, at this point, you might wonder why this local variable are useful, but I really encourage you to use local variable, because if you don't use local variable, the value of a variable can be messed up from within and outside function. And function, you really want a function to be a black box that does what you want to do, regardless of the outside world. It takes in some value, it computes it, it does something, and then it gives something back. You don't want to mess. You don't want to change and mess value from inside and outside. So I really encourage you to always use local variables. In this section, we will deal mainly with computations in the terminal. The first thing that you're gonna see in the next lesson is a complete reminder of how basic arithmetic expression works in the terminal. So I directly took the whole lesson on arithmetics from my course Bash Shell Scripting Crash Course, and I put it for you so that you are reminded of how basic arithmetic works in the terminal. However, the main point of this section is to show you what are the problem of this arithmetic. So after this lesson on basic arithmetics with a terminal, there will be a lesson where I show you the big shortcomings and problems of these computations. Once you understand that, I will then show you the right environment to perform clear and advanced computation. At that point, we will have all the pieces that we need to face our final script. And in the final script, you will see how to make advanced and clear computation. So see you in the next lesson. So the first script that we will create is a script that will allow us to perform neat computations, clear computations. Because as you know, the way you do computations in the terminal is using this arithmetic expansion here, and we get our result. But this kind of computation has a lot of terrible problems. First of all, if you want to use something like power, like 3 to the power of 2, you use an expression like that. And this is okay, but if I want to use negative power, for example, 3 to the power of minus 2, which is 1 over 3 to the power of 2, which is 1 over 9, I get an error. But even worse than that, we cannot perform division, because if you do a simple division like this will work, it gives 2. But other than that, we will get numbers like that. 10 divided by 3, it's equal to 3, which is not true. It's simply wrong. And this is because this does not allow us to have decimal. So for example, 1 divided by 2 gets us 0. Okay, so this is completely non-good for us if we really want to perform computations. So what do we do instead? We will make use of a command inside the terminal that open a completely new environment, and this command is the command bc. And when you type this bc, you enter in this completely new environment where you can do all the computation you want. So in the next lesson, I'm going to show you the details of this command and how to use it. And after that, I will show you how to make use of this environment in our script. And this is going to be very important because this is going to teach you how to run a script that goes inside an environment, new environment like this one, do whatever it wants to do and goes back. And this is very, very useful. So let's see how this bc command and environment works. We go inside it and we can do, as I were telling you, all the computation that we want, like this, in a similar way that we were doing before. 3 times 5 is 15. And now if we try and perform a division, the first thing you might notice is that it seems that we get stuck. So again, it seems we don't get decimal, okay? But the nice thing is that inside this environment, you can set a variable which is called scale, which is exactly the number of decimal that you want. So for example, if I type 2 and now I hit enter, now scale is set to 2, and if I go like 1 divided by 3, I get 0.33. I get my 2 decimal. If I want to change that and I want, I don't know, 5 decimal, and I go again like this, I'm gonna get my 5 decimal. So this problem is completely solved, okay? In order to quit this program, you have to type quit, okay? And we are out. Another nice thing of this program is that you can call it with option -L. -L set the decimal point to a default value, so that if I open the bc command, the bc environment like that, I right away have a lot of decimal. But again, this is always true that you can set the scale with as much decimal as you want, for example 1. So now if I do something like that, I'm gonna get my 1 decimal. Let me show you something else so you understand the power of this environment and how many things you can do with that. First thing, you can set variables. A equals to 12, b equals to 0.32, and then I can do whatever I want with this. So a times b, for example. Also, you can, of course, use power. So 3 to the power of 5, or you can do, I don't know, 3 to the powers of 2, but also 3 to the powers of -2, which is 1 over 3 to the power of 2, or 1 over 9. And in fact, I get 0.1. This is approximately 0.1. If I want a more decimal, we can set the scale to, I don't know, 5, for example. And then I go back to this and I hit enter, and you see that you get slightly more than 0.1. This is exactly 1 over 9, in fact. Also, you can use more complex computation like the square root of a number, like SQRT. This is how you use the square root of a number. Square root of 16, which we know is 4, and we get 4. And of course, you can do that with all the numbers that you want, and you can combine all these elements, like 3 plus 5 to the power of 2 minus 12 times square root of 15, say, and we get the result. The other thing that I want to show you is that you can also use Boolean expression, which can come in handy many times. For example, if I type 10 is less than 3, this is not true, so I will get a 0 as in false, not true. If I type 10 less than 20, this is true, so I will get a 1. And I can combine those in the way that you probably know with Boolean expressions. So for example, I can combine this expression, 10 is less than 20, which is true, or in the usual way with this double vertical line, or 1 is less than 10. Now they are both true, so I will get true. If I use, if instead I say 10 is less than 3, which is false, I will get a true statement or a false statement, and true or false is true, so I'll still get 1. Another thing that I can use, of course, is the AND Boolean expression. So this expression and this expression. So this expression is going to be true if both of those expressions are true, but in this case we have a true expression and a false expression, so these are not both true, and so I will get a 0, a false. And in this way you get the idea. The last thing that I want to show you is the length command. The length of a number is how many digits it has. So this has 3 digits. Even if I use a decimal number, this has 6 digits. Instead, if I just want to count the number of decimal, I use scale. And you might remember that scale is exactly what we used, what we set at the beginning of our program. So the scale command here tell me how many decimal number I have, and in this case I have 1, 2, and 3, and in fact I get 3. And of course, if I use a number like this, it has no decimal, and so I get a 0. So let's quit this environment now. Let me tell you one last thing that we will use for our script. It is useful to have this program running without this copywriting stuff at the beginning, and so you can do that by using the option -Q, which usually is an option that stands for quiet. So open up, do your thing, but quietly. So if we use that in this way, we get inside the environment with no stuff printed whatsoever, and we can start do whatever we want again, and we can quit. In the next lesson, we're going to see something that will be very important for our script, which is how can we use a command like this that open a completely new environment without entering in a new environment, just using this directly. And to do that, we will use redirections, which are very, very important in shell scripting. In this lesson, we're going to see a way to redirect the input. So, for example, if you use a command like cat, you probably use that to show the content of a file, for example, like this. And we can see that the content here is hello. But if you use cat without any argument and you hit enter, it will wait for your input. And the input, of course, always comes from the keyboard. And so whatever I type, like something like this, I get the same thing. And we can close it with Ctrl+C or Ctrl+D. Now, what if I want to change or redirect the input of cat? I can use the command that is called the here document. This is the command that is called here document. And what it does is it will redirect whatever I will write here now as an input of cat. The only thing that you have to do here is to type a symbol that will be interpreted as the end of the file, because if I start typing something here, how can the program know when the file is ended? So here I have to type something that will be interpreted as the end of the file, and it can be whatever you want. Let's say I use this symbol here, capital AAA. So I hit enter, and now as you can see, I can start typing whatever I want. And as soon as I type AAA, this is gonna be the end, interpreted as the end of the file, and so this will quit, and all of this will be given as the input of the cat. And as you can see, that's what happened. Of course, you can use whatever kind of end of file that you want. Usually people use something like this to be sure that it is clear that this is the symbol for end of file. So I start typing, and then whenever I type this, this ends. Now this here document is called like that because in a way it is as if what we type here is a document that goes inside the command that you're using here, and you can use it with many commands, and in our case we're interested in using it with the BC command, because now you can understand that if I use it with the BC command, I can redirect whatever I want inside the environment of the BC command. So let's use EOF, simple EOF like this, and I hit enter, and now I can do whatever I want, like 3 plus 2, 4 times 5. I can even set variables, a equals 10, and then I can do, I don't know, 20 times a, for example, and I type EOF, and what you get, as you can see, everything here is redirected to the BC command. So I get 2 plus 2 is 5, 4 times 5 is 20, and now a is set, and 20 times a is 20 times 10, that is 200. What you learn here is extremely useful as per itself, but we also will use it in our script, as you will see. A similar input redirection that I want to show you is the here string redirection. Let's say that I want to redirect the input not from a document, but just from one string. We can use the command that is called the here string. And the symbol for this command is this one, 3 lower than sign. And the syntax is the following. We have whatever command we're using, we have our string, and we have the redirection command here. If usually this command take its input from the keyboard, this redirection here forces this command to take its input from this string instead. So let me show you that with cat. If I do cat and I use some string here, now cat took as input this string, and as you can see, it print this back. To show you that it's really a redirection from a string, we can actually create a string and a variable. Let's say that s is our string, our new string 1, 2, 3. And right now inside s we have this. Now we can use cat, and then we give as an input this string, and as you can see, the redirection worked again. This redirection of course works with every command that can take an input from the keyboard. So for example, the BC command as well. We can redirect the input of BC from a string like that, 3 times 4, and as you can see, it works normally. And to show you just one last example that we are going to use extensively, the read command is a command that take an input from the keyboard. So we can use the here string in this case too. So we redirect read, let's say W, and we redirect. This is my value. So now inside W we have our string. As the last example that I want to show you, we can save inside the variable q a string that contain a computation like 3 times 7 plus 5. Now we can use BC and redirect this string q inside BC. So it's going to get this computation with this, which is 3 times 7, 21 plus 5, 26, as you can see. So in this lesson we saw how we can redirect an input for a command directly from a string and not from the keyboard. And we saw that we can do that with a here string command. So now we have all the pieces together to face our next script. In this lesson we will see how to use scripts with parameters. We already know that every command in our terminal is an executable script like the ls command, and we know that it can work on its own, for example like that, or it can take parameters like the name of a file, for example like this, or options like in this case. And an option for a command actually is just a parameter that we pass to the executable shell script of the ls command in this case. So we get a different output using this parameter. Now, how can we use parameters in our shell script? This is pretty straightforward. Let's open a shell script that I prepared here. We can access the first parameter that we give to our script just by the symbol $1. So for example, let's write, this is parameter 1 and we write $1. Let's save it and run the script. We don't get anything because we didn't give any parameter to it, but if I gave something, you can see that we have our first parameter here, and this goes for as many parameters as you want. So this is parameter 2 and we can access it with $2 and so on and so forth for the other parameters. So in this case, we will have, if we run our program with different parameters like this one or even numbers, that we have all this kind of parameters. And of course, if we don't put all of them, we will have empty spaces. You can also add parameter as strings with empty spaces, but we will have to use commas for that, like this one parameter. And the last thing that I want to tell you is that you have to pay extra careful attention if you want to use a number for a parameter that goes beyond 9. So if you want, for example, to access parameter 12 and you try and do this, this will be wrong. As you can see here, if we add many number of parameters, you'll see that as parameter 12 we get Q2. And this is because when you try to access this, $1, 2 will interpret $1 as this parameter here. It will access this variable here, and in our case, the first variable is Q, and then 2 will be just interpreted as a string that we add to this. So the right way to access parameter 12 is to use the proper variable expansion, and so to use curly braces in this way. And in our case, the 12th parameter is 1, 2, 10, 11, 12 is the U. So if we do that again, we get the right answer. Now, what if we want to count in our script how many parameters we have? There is a shortcut to do that, and this is by using the $hash. This is the number of parameters. In this case, we have 12 parameters. And of course, this works with any number. A very useful way to access all the parameters is via the symbol $at. This will access all our parameters, as you can see here, all parameters. And this is useful if used in a for loop, for example, to run over all our parameters. So if we do a for loop for I in $at do, and as you can see, we have a for loop that goes through all of our parameters. Now, this is true that you can also use this other symbol here, the $* standing for every parameter, and also in here this does exactly the same thing, as you can see, but these symbols differs when they are used inside commas. So this symbol is different from this symbol here. In fact, if we do this now, what happened is that this symbol here with commas will be interpreted as all the parameter as just one whole thing, one whole parameter, one whole string, if you will. So in this case, if I run this, you can see that in the for loop there is just one item. It just looped once because it considered this as just one element. This is not the case if you use the $@. So this is more convenient usually to use this symbol instead. If I save it and run this in this way, as you can see, again we get a loop over all of our parameters. So now I am in the position of explaining to you the shift command. The shift command lets you shift the parameter by 1. So for example, if here I use the shift command, what happens is that all the parameters are shifted by 1. So for example, in this case, $1 is a first parameter. So in our example, if we write that would be A, and $2, that would be the second one, so B. But after we use the shift command, the $1 will refer to the second parameter and $2 to the third parameter. So if I use those again, what I get here is that now $1 will point to the second parameter, and so will be B, and $2 will point to the third parameter, so it will be C, and so on and so forth. So if we save this and we run this, as you can see, we get up to here. We have that parameter 1 is A, so the first one, and parameter 2 is B, so the second one. But now we have that parameter 1 after the shift, so $1 is the second one is B, $2 is C, this is D, and so on and so forth. And you can see this also, of course, in the $@ or $* symbol, where you can see that our parameters starts from B, because $1 is changed to $2 and so on. And also, of course, this affects the numbers of parameters, because since we are moving everyone forward of 1, we will not get A. And you can use the shift command with an option of the number of steps that you want to shift your parameters. So for example, if you want to shift by a factor of 3, you can type 3 here. So $1 will point now not to the first one, but to 1 plus 3 equals 4, so to $4. And $2 will point to $5. Okay, so if we run this again, first two are unaffected again, and then we have here that $1 is now pointing to $4, which is the fourth, 1, 2, 3, 4. And in fact, we have D. And as you can see, we have much fewer parameters here, just 4. And of course, you can shift off as many steps as you want. For example, let's shift off 6. And of course, here you will see that we just get 1 parameter because everything else was shifted too much outside the scope. The last thing that I want to tell you about this, and I left this at the end on purpose because it's not as important, is that there is also a $0 parameter, the absolute path to your script. So if I use $0, I'm gonna get the exact path of par.sh. Let's save it and let's run this. And as you can see, $0 will give me the absolute path here. So this is great because now we have all the elements. We learned about all the elements that we will need to build our real-world shell script. So we are finally in the position to create our calculator script. And this should be the command like calc that has to allow me to perform simple calculation like this one, but also calculation that arithmetic expression cannot allow me to do. So for example, calculation like the division, like so. And also be able to do that with the precision that I want. So for example, if I want a precision of 10, I can use my script with the -p option and telling him, hey, I want a precision of 10 digits. So I add 10 and then I do my computation like so. And also do many and more complex computation, like let's use precision of 3, then use a computation like, I don't know, 12 divided by 7, and then plus 8 times the square root of 18, and so on and so forth, as complex as you want, all right? And do that with the precision that I want, either 1 or 20, okay? That's the script that we want. And the nice thing is that if you followed all the part, if you learn all the pieces that I taught you in the previous lessons, now this should be really a piece of cake. Let's see how we can do that. So what we want to do is to use the BC command in order to perform our calculation. How do we do that? We use the here document command. We use this symbol as the end of file, and now whatever we put here will be passed into the BC environment, and so it will perform all the computation that we write here. So what computation do we want to do? Well, we know that we will pass to our calc script a computation as the first parameter of the script. So we can pass $1, and that's just it. After that, we can give the input of end of file, and we will be out of our computation. And so let's try this simple version of our calculator, calc.sh. So if I use calc.sh and I don't do anything, I just get the echo command, 2 plus 3 get 5. But if I do 2 or 12 divided by 7, I don't get the answer that I want with the decimals. So what I have to do here is, of course, to add the scale. I want a scale to be, let's say for the start, let's say with 3 decimal point. I save it. Now if I run this, I get my answer with 3 decimal point, okay? Now you can observe that if I do something like 3 plus, for example, 4, and I leave a space, I get an error. And that is why this can be interpreted as a second parameter to our script. Since we don't want that, what we can do is to change this into the whole parameter symbol, that is $at. Now we save this, and if I run something like this with a space, we don't get the error. Everything is working fine. Now at this point, we want to be able to use the precision that we want. So this scale should change depending on what we decide it to be. So of course we need an if condition. So if, and the condition is, if the first argument, the first parameter that you give to my script is the option -p, as in precision, $1 is equal to -p, then let's set the variable precision equal to what? Well, you see, the first parameter is this one. So after this, the user will put the number that he wants as the precision. So the precision should be the second parameter, okay? Else, if the user doesn't want to use the option precision, well, precision can be set as, for example, again, 3. Now again, we use the here document to perform this inside the BC environment, but we set the scale exactly as precision. Now let's save it and see what happened. We use calc.sh with a simple computation like this one, and it's fine, or this one, and it is fine. But if we use this, let's see what happened. Let's use our option -p with 5 as precision and do this again. We get a problem. Now, what is the problem here? The problem here is that in this case, if we use the whole parameter symbol $at, we're accessing all the parameters of our script. And let me show you that in this way. Let's echo out $at variables. Save it. Let's do that exactly as the same. As you can see, all variables is this, and there's no way that the BC command is going to understand what this means, of course. So what we need to do is to just give this value to BC. Now you might be tempted to say, okay, this is 1 to the third parameter. So let's give it the third parameter, but that would be an error too, because in case that the user is not using this option, so in case that the user is just doing this, we will have just one parameter, and so we should give it the first parameter. So how do we solve this problem? We use the shift command, and we do that here. In case, and just in case, we are having the -p option, the precision is set to the second parameter, and we shift off 2, so that this parameter and this parameter will be ignored, and $@ will remain just the third parameter, so just our computation. Otherwise, we don't shift anything, because we will be in a case like this where we have just one parameter, and so $@ in this case will be just this guy here. So let's save it. Let's see what happens. Start with normal computation. Let's get rid of this check here. 12 divided by 5. All good. Now let's use our option -p to get 10 decimal numbers. 12 divided by 5. And now everything is working fine, as you can see. So very good, we finally have our calculator script. And if you look at it, this is pretty short, right? But finally we have a really powerful tool to make all sorts of computations, and also with the precision that you want. And this is a tool that you can use many times inside other script when you want to have a clear way of computing something, and the result of that you're going to use inside your script. Also, this is a very dense script because it's full of important aspect of bash scripting, starting from the if condition with the parameters, the bc command, and the here document, and also the use of all parameter with the $@ and the shift command, which really shows you how you can handle in any way a script that has option, for example, and you want it to behave differently according to the user will. So very good, play with this script, use it inside other script, and if you want, tweak it and change to your own taste. And see you in the next section, where we will learn more about bash scripting in a practical way, learning more real world bash scripts.